everyone. Welcome to another episode of Mastermind Academy. Good to have you. We've made it to just about the end of the week. We do have office hours tomorrow, but we have made it to the end of the week, which is nice. End of the work week in particular. So tonight we are going to be diving into a lot of the cool stuff. We're going to be diving into how we serve the masses. How do we scale up? How do we serve the masses? How do we make enough infrastructure, and how do we operate our infrastructure in a way that can serve lots of people all around the world? So those are going to be the concepts that we're going to be diving into tonight. It should be a good one. We should we need to get started now. Basically, there's a lot of information in here. We're going to try to get hands-on and build a load balancing pool, hands-on, and we're going to try to build we're also going to try to put together we're going to do some stuff with S3 from the command line, and we will also try to set up a static site in S3. We'll see how time works for that. If not, I'll just show you some implementations of static sites in there, but hopefully we'll be able to get hands-on with that. What's up, Uber King Kong? Good to see you. How are you, Manuk? How are you doing today? Well, let me grab everything that I need to grab really quick. Remove this. Like I said, we should get started immediately because there is a fair amount of information in today's class, and let's make sure everything did drop inside Google Classroom. Let's see here. Cool. Slides are available. I'll open those up. Let me make sure you can all get them. Let's update the slides command. Let's get it going. Slides. Edit. What is this? Slides. Let's change that. 1 second. And it's just getting set up here. There we go. You should be able to get the slides now if you need them by typing in slides if you don't have access to Google Classroom, but you should be able to get it. What's up, Aban? How are you doing? Thank you, Mysterio. Appreciate it. I don't wear this shirt that often anymore. I used to wear it a lot. I don't wear it that often now, because it's, you all have those shirts that are like hard to get off. Like it's hard, like, because it doesn't stretch. I think that's the biggest thing. This is the only shirt I have. Well, I guess besides like a button down. Like button downs generally don't stretch usually, and like this has no stretchiness to it, and so it's like hard to like get off. It's just dumb. I don't wear it that much, but I do like it a lot. You know, just I go for function over form nowadays. You know, I'm an old man. I appreciate that. Do I need to be up to speed with the other Horizons classes to attend this one? No, not at all. These concepts do not build on anything we've done so far. We will probably be diving into some EC2 stuff, but no, you should be completely fine. These concepts are standalone, and I think you'll be able to get a lot out of it regardless. Probably because of them Pythons you rock. Hey man, like I said, I need to get back in. I've been in the gym in like a week and a half because I've been working on a bunch of stuff. Really sucks. I'm really trying to get in there, and I'm trying to. I'm telling you, I'm trying to get tiny first. I'm trying to get tiny, and then the goal is to look like Dwayne "The Rock" Johnson. I've been on the journey for a while, but I'm gonna get tiny first. I'm gonna switch it up a little bit. I'm gonna get small first, and then I'm gonna get down to The Rock's weight. That says a lot. The Rock is like 6'3", 6'4". He looks super jacked, but I weigh more than The Rock weighs. So I gotta get down to his weight first, and then we'll make it happen. All right, those only stretch one time. Exactly. Shirts like that, you stretch them once, that's it. So let's get started because there are a lot of concepts, and I would like to get hands-on with some of these things because it makes a little more sense when you dive into these things hands-on. All right, here we go. So tonight's topic: serving the masses. How do we make sure everyone can access our data? How do we make sure we always provide uptime and availability to the things that we're doing? That means tonight we're going to be talking about the big cloud concepts. These are the cloud concepts that people care about the most. These are the types of things you're going to get questioned about in interviews, talking about scalability and availability and all that stuff, is elasticity. All these things are what we're going to talk about tonight. So balancing the load and scaling automatically is the first thing that we're going to talk about, and then we're going to do a deep dive into Amazon's S3 service, which is arguably, while EC2 is the backbone of AWS, S3 is probably their keystone service. It's probably I feel like it's got to be one of the most utilized services, if not the most utilized service. So we will dive into that. What's up, G Billingsley? How are you doing today? I hope you're having a great day this amazing Friday. But yeah, simple storage indeed. It really is. It's a really cool and versatile product. And so we'll talk about those things. So let's do it. Perfectly balanced as all things should be, unless you need more. So load balancing. Load balancing as a concept. This is a concept that lies outside of AWS, not specifically in AWS, but load balancing. In computing, load balancing improves the distribution of workloads across multiple computing resources. We'll stop there. Distribution, it separates the load, it separates the stress, the traffic across multiple computing resources. So instead of all the information going to one and being processed by one, load balancing allows us to balance the traffic coming in and the workload across multiple computing resources, such as computers, a computer cluster, network links, central processing units, or disks. So we learned that everything in AWS is a resource. And so we can apply this concept to a lot of different things. But this what we're usually talking about when we're talking about load balancing is balancing network traffic over a bunch of different resources. So usually a couple different servers or something like that, and making sure that we're able to handle it by having multiple resources and spreading that load out across multiple ones so that they can all help do the lift. What's up, Fred? How are you doing today? Good to see you. Welcome. Come on in. We're just getting started. My glasses are dirty. I don't know how they keep getting like this. I know they're scratched up, like I said, but they're also extremely dirty, making it hard to see, making everything look hazy. All right. Here we go. So this is an image of load balancing, how it might work. So generally when we've already seen ourselves set up an Ec2 instance, we set up one computing resource, one server, and we set up some stuff on it, and we were able to hit that service, and that was processing our requests and sending things back. That's great. That's phenomenal if there's one of us or a couple people hitting this thing at any given time. But think about all of the major applications that you go to every day. Think about things like Instagram and Facebook and Twitter, all these things, Google, everything that you go to every day. Imagine if you have hundreds of thousands or millions of people hitting this thing every minute or even every second. To be honest, it gets pretty tough to manage that. And web servers themselves are actually pretty fast, can actually handle lots of requests because basic web requests are generally pretty light. But they're usually the application needs some processing by a server in the background when it's actually responding to that request. And that is the part that really sucks and takes up a lot of computing resources. And so inbound traffic for load balancing goes into one centralized point, being that load balancer. And the load balancer takes it in and does its best to distribute that load to other servers, to each of the servers that it has in what's called a server pool. It has a pool of resources that it can send traffic to. And so it all goes in one and it gets distributed amongst multiple. That pool could be any number, even just two, even one. And so it makes it so that these background servers can process the requests much more evenly, much more efficiently. It also means that you can now serve more and more people. And so you might say, oh, well, why wouldn't I just possibly have 3 different servers to send my stuff to? Well, networking and DNS wouldn't really allow for that in any type of easy way. But even if somehow we could just throw 3 servers together in a cluster and be able to do this, the problem is that what load balancing does is it makes sure that not only one server gets overloaded. So let's say we got 2,000 requests this past second. It could be the case where this server up here, server number 1, gets 80% of those requests, and that may be fine. It may be fine the way our setup is, but it may be a terrible thing to have happened, and we might be underutilizing these other 2. But while balancing the load, we can ensure that we give as consistent of an experience as we can figure out, as we can get. And so load balancing is pretty dope. There's a very simplified image of it, but this is essentially all load balancing is, and this is the way that I need you to understand it, just like this. Traffic comes in to the load balancer balances that load across whatever resources it has available in the pool. Okay, cool. What's up? No ref check. Sorry, I tried to read it. It's end of the week, waking up a little bit, not gonna lie to you guys, had a long day, waking up a little bit, so welcome. Happy Friday to you as well. All right, so how does it do this, and what ways can it do this? Let's keep this last image in mind. keep it in mind that we have a load balancer and we have 3 servers sitting behind it. How does this kind of work? The first way is round robin. And this is the kind of de facto way that people probably think about load balancing. And it's probably the most used algorithm for load balancing. And the way round robin works is it says, let's open up a whiteboard really quick. Round robin says we will send each subsequent request to the next server in line. So the way that we do this is, let's say we have our load balancer up here, and I'll just put LB for load balancer. And there's requests coming in from the top here, and we have 3 servers down here. 1, 2, 3. What it's gonna do, what round robin is gonna do, it's gonna say, cool, we'll send request number 1 over here. So this is request number 1. Request number 2 will go here. Request number 3 will go here. Request number 4 will go here. Request number 5 will go here. Request number 6 will go here. So round robin is just, it continues to cycle that around. That's great. That might upfront sound like the best option. Why would we ever need anything else? If we're trying to spread the load across all servers, why in the world would we do anything besides this? This makes sure it's even. Well, we have seen, the requests that we've seen have been pretty immediate. We make a request, it gives us a response, it's all good. We haven't seen what happens when it's an application, when things need to be processed. It could be that, let me back it up a little bit here. It could be that this first request that goes into number 1, maybe for some reason, maybe this request takes, a long time. Maybe it takes 8 seconds or something. We're getting a bunch of different requests. It could be that requests are not done processing on this server when number 4 gets sent in. And so that's not a problem. The server can usually handle, it can handle multiple connections and things like that. But when we're talking about thousands of connections, hundreds or thousands of connections, this can become problematic. And so you may get it to a point where you're kind of cascading, and where the more requests you're sending to a computer, the longer the requests actually begin taking. So you might start to stack up requests on one system. Even though you're spreading them evenly, there might be one system that's taking a little bit longer to process. And so you can get, this does not mean you are going to get even response times, or as even as response times as you can get. It may not be the best option for you. It might be, but it might not be. But round robin just says, hey, go, serve the next subsequent server. So, 5 and 6, just keep going around in that loop and applying it to the next server in the pool after a request is sent there. Okay. So that's round robin. The second one is weighted round robin. Okay. Weighted round robin might be a little bit better for a number of reasons. Some of the reasons why weighted round robin will be better is if maybe you have some of the systems in the pool, maybe you have some systems that are more powerful than another system, or maybe one of the systems, or maybe a few of the systems in the pool, yeah, they're serving web requests, but maybe those servers are also serving some other type of job. So there's other processing going on in there. And so you may not want to send as much traffic to those servers. But what weighted round robin does, I'll make sure this saves, because it does. That's why I like this whiteboard. I can do it for all of these. And let's see if we can draw these same squares again. And we'll put our load balancer here. And this is weighted round robin. And what this says is, let's draw our 3 servers here again. What this says is we can apply a weight to each of these servers. So maybe I say, hey, let's say maybe web server 1. Oops. Let me say web 1, web 2, web 3. That's going to be the name of our service today. Let's say we want to give this a weight of 3. And maybe we want the weight of these 2 to be 1 each. This means that web server 1 is going to get 3 times the connections. It's going to get 3 times, it's going to get a ratio of 3 to 1 connection. So the first 3 might go here, and so it may not be the first one, but it depending on how many requests are going through at any given time, web 1 is going to receive request 1, request 2, request 3. This is going to get 4. This is going to get 5, And then we're gonna go back over here. It's also gonna receive request 6, request 7, and request 8. Okay, so it's going to get 3 times the traffic as the other 2 servers. All right, so you can apply weights to any of the servers. You can say, hey, both of these servers are a weight of 3 and then 1. And then so it'll break down the ratio and it'll make sure that more traffic goes to the server that is weighted heavier. And again, the scenario in which you might want to use this is if you have servers of different sizes. Maybe Web 1 is a super beefy server that we had in-house or something like that. And well, maybe not in-house, but it might have way more resources than the other 2 servers or the other servers in the pool. Or maybe those other servers in the pool are responsible for doing other tasks as well. And so that's when you would want to use a weighted round robin load balancing paradigm. And so again, this is not specific to AWS. While we are going to show how to do these things in AWS, these are web concepts. You can take this along with you to however you're hosting an application. You can do these things with Nginx. We saw how to spin up a web server with Nginx. Nginx has these capabilities. It has the ability to do some web server, a lot of this web server stuff. So just keep that in mind. The concept is what you want to focus on, and we'll talk about how it applies to AWS. Least connection. Least connection is someone just said it in the chat. Just cool said it in the chat. Least connection is exactly what it sounds like. What it will do is it will send the request to the server that has the least amount of connections. And so this is generally the one that's going to, it may not give you the best spread of load. It might, you know, every situation is going to differ, but I should have made a little base app so I didn't have to keep drawing these boxes. But what this is gonna do, we'll draw them faster. Oh, we got little trapezoid servers over here now. It will say, let's say maybe there's a lot of things coming in, and maybe right now this one's currently still processing 3 all at once. Maybe this one is processing 2, and maybe this one is processing 2. And so it's gonna pick the one that has the least amount of connections. It says, hey, this one is still only processing 2. So when I get this request, I'm gonna check how many connections are sent there or still open there, and I'm gonna send a request over so I can even it out as much as possible. And so least connections will allow you to send to the server with the least connections when the request comes through. And so this is usually a good paradigm. A lot of people default to least connections because it does generally, it makes a lot of sense, especially for normal web server usage when you don't have a super complicated application. You know, hey, give it to the server with the least amount of connections, and we're generally good to go. Estimated weighted moving average. That it is not an exact science, 100%. It's tracking because it might be getting thousands and thousands of requests at once. And so it's going to do its best to kind of, you know, crunch those numbers quickly and send it to the best place. It won't always get it right, but most of the time, it'll average out to be right. Thank you so much for the gift of sub yesterday. Absolutely, I didn't see it this afternoon. You're a legend. I mean, maybe I gifted it, but Llama Kid, I'm glad you got a gift of sub. Again, I'm super glad that you don't have to watch any more ads. That's great. Is it possible to have, is it possible or common to have these methods combined? That's a very interesting question. I have seen scenarios where people have multi-tiered load balancers, which is, I understand. I think that's an edge case, and no, not in the same. So yes, you might use them in concurrence to handle completely different sets of the application, but they may be different pieces of that make up the experience of one application, but not to the same piece of the application. I've never seen it combined before. But like I said, I have seen it be multi-tier. I have seen one load balancer where the resources that it is accessing is 3 or 4 other load balancers that are operating in different fashions. You know, it gets super deep into your use case when you're talking about stuff like that. Weighted least connection. I'm not even gonna go draw that, but same thing. It's still gonna look for least connections, but it's going to allow you to provide a weight to servers so that some can be weighted heavier or less. The more connections can be served from different servers in the pool. That's good. And source IP hash. This one is this is a really good one for, you're gonna use this a lot, especially when you have an application. This is gonna help allow for something called sticky sessions, or can allow for sticky sessions. What it's also gonna do is possibly provide a better experience to your user. What source IP hash says is, I'm going to basically when I'm going to create a hash when you come to a system, you're going to have a unique IP address. It's going to basically take account of that, and it's going to note basically where it sends your request, and it's going to do its best to send your request back to the same server that it sent it to before. It's going to try to keep you and your connections on the same server, and this is something that people do a lot. Persistence. It'll a persistent connection. It'll do its best to keep your session in the exact same server. And again, this generally, the way the applications are built now, this generally isn't that much of a problem, but it can be. It definitely it can cause some issues depending on how your application is built. We have covered this, but can you run multiple servers and load balancers from one EC2? Good question. Run multiple servers. So that is a loaded question a little bit, but first, let me give Large Data Bank welcome to the channel. Well, come on in, everybody from Large Data Bank's channel. You're all probably watching ads right now, but Large Data Bank, good to see you. Welcome to the channel. Shout out to Large Data Bank. Thank you so much for the raid today. We're here just talking about some AWS concepts or concepts in AWS, and we got a lot that we're covering a lot today. We're pretty early on. Hope you had a great stream. What was your stream about today? What did you do? How'd it go? I really want to know. I'm not a large data. Data's it's a thing, and I know how to work with data, but I don't know how to work with large data banks or data lakes or data warehouses. I know what tools you can use in AWS to get to them, but yeah, some open source cleanup for Cockroachdb. I haven't had a chance yet to dive into Cockroachdb. I was going to use it for a project and I never got around to it, so that's pretty interesting. Maybe a good opportunity to check out Cockroachdb. Cockroachdb is NoSQL, isn't it? I think is it NoSQL? Pretty sure it's NoSQL. I do want to check it out. Can't remember. Oh, it's relational? I did not know that. I did not know it was relational. Okay. It's SQL. Interesting. That's awesome. I definitely will check it out. We'll talk. I have a lot of questions about databases. Just a whole lot of questions about databases, but cool. We're gonna keep going with some of this stuff. So, Chris asked about the multiple servers and load balancers. It's loaded in that no, you can't run multiple. Probably in the way that you're thinking about it, you can't run multiple servers. You can run as many services as you want, but you can't really run multiple servers from one EC2. The EC2 is the compute, it is the server, but there are ways, using Docker or something, there are ways to run, or depending on the application you're doing, you can run multiple web servers if you'd like, running on different ports or something, but you got to do some fancy stuff all around that to make it work properly. For a load balancer from one EC2, again, theoretically, you could run multiple from there. I don't think it would work how you think it would work, how you would want it to work. I don't think it would really make much sense to do it that way. But yeah, I mean, you could, but it'll be magic, kind of. And maybe we can mess around a little bit, because maybe we'll log in and do some stuff in a second. All right, so those are the different algorithms. There are more algorithms than this. These are the common ones to determine how traffic is routed amongst those server pools, okay? Yes, I am telling you there's a chance, 100%. All right, server pools. This is a pool is a collection of origin servers that your load balancer can send requests to. So when we go back to here, everything that is right here, this is your server pool, okay? This is a server pool. It can have any number of servers in it, but everywhere, the place that your load balancer can send the server, the request to, that is the pool. That is the server pool, okay? A pretty simple concept there. In AWS, these are called targets. That is a good thing to know. They might ask you that on the exam. So the servers that a load balancer can send requests to, they're called targets inside of Amazon. But these are server pools. Okay? Does VPN mess with source IP hash? Because yes, 100%. That is a phenomenal question. Yes, it does. It does, but there are ways. there are a number of checkpoints in the networking stack that you can use to fix that, but also it may not be work. I mean, it all depends on what your requirements are for your VPN. But yes, that it will affect it. And your source IP hashing may be relatively useless because everybody has the same stuff. That's why your application needs to be built in a way that that doesn't so much matter that you need to be on the same server. But yeah, good question. Okay, so health checks. How do we know a server in the pool is good to go? So this is a pretty important topic of load balancing, and this is kind of what starts to make load balancing really fancy, really dynamic, really important. So a health check simply attempts to open a TCP connection. You don't need to worry about what TCP is yet, but it tries to open up a TCP connection to the instance on a specified port. Okay, so ports are simply channels of communication. By given the number, we talked about them a little bit before. If there's a failure to connect within the configured timeout, this pool, this server in the pool, this node in the pool, this target is now considered unhealthy. So these health checks are reaching out to make a connection and doing their best to determine if a server is healthy or not. Unhealthy hosts will be removed from the pool. So automatically, you'll specify a scenario. You'll say, hey, this is where I want you to check. I have a web page here that should be accessible at all times. I want you to check, attempt to connect to the server over this port and check this thing. If you should receive a certain amount of timeouts or a certain amount of failures over a certain time period, I consider that unhealthy, and I would like you to remove that server from the pool of servers that the load balancer can send requests to. And that's good because if something happens to a server, it can automatically trigger the removal of itself. So it can automatically, if you don't want people to be able to have requests go to a broken server, or else they'll get errors back and they'll be confused and they'll have to refresh, and maybe their request will go somewhere else and it'll work, and it'll be a weird experience. You don't really want that. And so you want it to kind of fail and be pulled out. And so it will pull the server out, and the load balancer will no longer share any requests to that system, which is pretty powerful. Yes, exactly like a heartbeat. It's exactly like a heartbeat. It's going to check in so often. It's going to poll on an interval. You can have it be 5 seconds, 10 seconds, 30 seconds, a minute, whatever you want it to be. Well, not whatever you want it to be. I think it generally needs to be between, I think 5 seconds and 5 minutes in AWS, but I'll check some of that. I know some stuff has changed with application load balancers recently, but it also, those health checks won't stop once it's pulled out. Those health checks will continue to run. And so maybe if you fix the server, or if for some reason, maybe the server just got overloaded for some reason and couldn't respond fast enough. But as all the connections get resolved or dropped or cleared, that server is good to go again. It can get pulled back into the pool as well automatically. So it's super effective for handling that. TCP is a protocol for connections. We're not gonna dive too deep into it, but there's TCP and there's UDP, and they manage the way that they send information and handle packets and things differently. TCP has packet checking, and it makes sure that all the data that you're expecting to be there is there, as opposed to UDP, which is faster for transferring, but it doesn't have any packet correction or packet checking. And so things like you watching Netflix, that's actually reaching your computer over the UDP protocol. And it's just piping data through, and you might lose packets here and there, but it's fine because you're sending so much through. TCP, on the other hand, it's the general protocol of the web and connecting to web pages. I do think I have a slide on that. I think that's something we are going to talk about a little bit later. I don't want to dive too deep into it, but I'll give you a little more context a little bit later on that. I was trying to keep it as a chill definition for now, because it's not crazy deep, but it's I don't want to give you too much altogether. So those are health checks to check in like a heartbeat. And if the server is unhealthy, it will pull it out of the server pool. When it becomes healthy again, it can put it back in the server pool. All right. I like it. Yep. Send act. There we go. There's the joke. Does anyone have any questions so far about load balance? Now, before we even talk about auto scaling, I don't even think I put in slides for this. I didn't. So, why do you why do you care about load balancing? Why do we care about what we're about to talk about next? What is all of this doing for us? Well, it's doing is we're all gonna build a web server in like 2 seconds. We're about to go in and build a web server. I mean a load balancer. Inside of AWS. We're also gonna do some stuff with S3 in a little bit. But what the goal of this is to be able to dynamically respond to the amount of requests that your system is receiving. It wants to make sure it's setting up methods and setting up ways to be able to handle traffic. Okay, so at any given time, we know how the people in the world work. At any given time, we can be swayed to go visit a site. We can go, a new meme could pop off, and we could be all sent to your site. These tools, these methods of hosting, allow us to be able to handle traffic effectively. So load balancing is one way, but load balancing by itself generally means you have to have the idea of it is you have a finite amount of resources in a pool. So maybe, I have ownership of 4 or 5 servers, and that's what I have. They're set up, they're ready to go, and they're here to serve whatever traffic is coming in. But what that doesn't address is what happens when you start to receive more traffic, and maybe very quickly more traffic than you already have provisioned resources for. So what happens when you've maxed out the capacity of those 5 servers? And this is where we're going to start talking about scalability. All right, it's scaling. Scaling, all it does is refer to the ability to be able to increase resources to match your demand. All right, so scaling simply means being able to increase the resources, the infrastructure to match the demand that you're receiving, the traffic or the load that's currently being received. It is perfectly synonymous with the word scaling when we're talking about business and being able to scale up to match, the demand there, and to be able to have more resources to be able to serve the population who wants your product. This is the exact same thing. You might hear scaling used with the term elasticity, or scalable and elastic and all that other stuff. So scaling resources might mean making your resources more powerful. It might say, hey, we have a server that has 1 CPU core and 8 gigs of RAM and this much throughput for my IOPS, for my storage, and we get more traffic. Scaling could be getting a larger server. It could be saying, hey, going from that 1 CPU server to a 4 CPU server with 16 gigs of RAM and many more IOPS, much more throughput on our storage device to be able to serve that traffic. This is called scaling up. Scaling up is when you are taking the resources that you have and you're making them more powerful. You're getting more powerful versions of these resources. Okay. The other kind of scaling we can do is called scaling out, and this is making taking the resources that we have and making more of them. Basically, scaling, adding that same resource multiple times. So in terms of load balancing, this would be like simply adding more servers. So we have that 1 CPU server with 4 gigs of RAM, and we're good to go. We're serving some stuff out. Scaling out would be saying, hey, once traffic gets high, let me get another server, and then adding another server to the pool, and adding another server to the pool, and another server to the pool. Okay, I'll draw it up for you a little bit, but that's scaling out, giving me more resources, giving me additional resources is scaling out. Giving me more powerful resources is scaling up. They work in tandem. You can do them both, and they provide different, depending on your use case, they provide different values, and we'll talk about that in a second. More questions after I'm practically harnessed the power. That's cool. Ask away. Are we gonna talk about horizontal? Oh, actually, Rusty, I just thought, yeah, we just went into that. We'll draw that out and we'll talk deeper about that as well. What do you mean the number of requests exceeded the amount of a single load balancer can take? So prop, this is not the load balancer I'm talking about. I'm not talking about the load balancer getting overwhelmed. You generally aren't gonna have to worry about the load balancer in AWS getting overwhelmed. I'm talking about the servers that are in the pool that it's sending requests to. Those will get overwhelmed. Overwhelmed trying to process all the data and try to get all the information that the requests are asking for. Those are the things that that will get overwhelmed. Again, resources on a computer are finite. When you make a request to Google.com, it's going off to a system, and a system is processing that data. It's having to spend CPU cycles to process the information that you requested and respond to you accordingly. And again, your computer can only take a certain amount. Each computer can only take a certain amount of requests at a given time before it begins to have serious problems. Let's see. Do we need to get the DNS configured or pick 2 or more load balancer, or how they interact to manage? Do we need to get the DNS configured to pick 2 or more load balancer? No, we don't need to do anything with DNS tonight at all, or how they interact or manage the pool. So if you're not, well, so tonight we don't need to do that, but if you're talking about how you would do it when you're trying to implement it, yes, you would basically have your DNS pointed at the load balancer. That would be the entryway into your application. Even if you had 1,000 servers, everything in that pool, everything would go through that load balancer. And so you would configure your DNS to point to that load balancer, and it would handle the rest. Again, web requests don't take a ton of processing power. Like routing them in the way that load balancers do doesn't take very much. And so you're not going to overload a load balancer. Also, these are scalable load balancers, very scalable load balancers that you don't have to really worry about. We'll see that in a second. It makes it pretty easy. You don't have to worry about that piece of it, but you do have to worry about the servers that are in the pool. Are those terms interchangeable with horizontal and vertical? Yeah. Does Pornhub use scaling? Yes. Guaranteed Pornhub uses scaling 100%. Everyone is using scaling because it saves you. I mean, it both saves you money and it allows you to offer the best experience possible. How does it save you money? You might be saying, how in the world does it save you money? Because remember the old way of doing things that we talked about. Remember in the past, you had to guess how much traffic you were going to get, and you had to buy a server that could handle your current traffic and allow you to grow. So you have to spend a bunch of money upfront for what you thought you might achieve one day, and if you needed more, you have to spend even more. What scaling allows you to do is to apply the appropriate amount of computing power to your demands. Okay, it allows you to better apply the correct capacity to what you're doing. So if I don't need 10 servers, I can start with one. I can start with one server, and maybe in the morning, maybe one server is enough because of the amount of people that we are getting in the morning, and maybe more people come on in the middle of the day. And so adding additional resources, scaling up to meet that demand, adding more additional servers behind it during that time is great. And maybe during the middle of the day, we'll be up to 11 or 12 servers. And then later on in the day, when the traffic dies back down, we can start to drop back down. And so this is where we introduce the idea of elasticity. Elasticity, so scalability is your ability to meet the demands of the requests that are coming through. Elasticity is your ability to grow and shrink your infrastructure and your needs depending on the demand. So being able to resize your environment, large and getting smaller in accordance to the demand is elasticity. And they go hand in hand, but scalability is specifically talking about being able to the ability to scale up to be able to add resources to meet demands. But yes, elasticity, exactly, just like a rubber band. Pricing models become important to know for scaling. Yes, we're going to talk about that as well. Pricing does become very important. And so I did say it saves you money, but it saves you money if you are doing it properly. It can cost you as well. Pricing models will also help you determine whether or not you would like to scale up or out. Both pricing models as well as speed of scale. There's a couple different factors that will help you determine whether or not you want to go up or out. Any value in getting the pro level AWS search? 1,000%. Well, 100. Yes, so few people are able to achieve the pro level search. I think they were saying, now I think things have changed a little bit, but at one time I think they were saying worldwide they were only certifying 13 AWS pros a day. Yes, 100%. there's a lot of value in it. The pro level AWS certs are much harder than the associate level ones, though. They are a whole different ball game. Like, they really are a different ball game of certification. The AWS Solutions Architect is the most difficult of the pro level certs. I for that reason, I've considered getting the DevOps one instead, because it's a little more focused into things that I really like. But the AWS Solutions Architect Pro is the toughest exam that they have. Projects feel better than certs, though. I agree that projects feel better than certs. Understanding how to do the things is better. But there is value in getting a pro level cert. There's a lot of, like, I wouldn't say there's necessarily a ton of value in. I think you have to be so. The questions make you have to know how to build these solutions so intimately that I think there's value, even if it's I think there's value in getting it for sure. I really do. All right, so auto scaling. We talk about scaling, auto scaling. Let's talk about that. Automatically scaling. And auto scaling is German for auto scaling. If you didn't know, go ahead and put it in Google Translate to confirm. 100% auto scaling is in fact the German for auto scaling. Yes, we will be setting up. We're going to set up a load balancer in just a few. We're not going to set up an auto scaling group, I don't think, because of time, because we're still going to go through a bunch of stuff tonight. But yes, we were about to set up a load balancer in just a few, which is going to be fun for me, because the last time I've set up a load balancer via the console and not via code was last time we did this, which was almost a year ago. And so it's gonna be, we're gonna have a little fun with it. Some things have changed about it that I'm familiar with, but I don't provision a lot of things. I do a lot in the console, but I don't provision a lot in the console. So it's gonna be kind of fun, but it should be pretty easy to walk through. We'll build that for sure. What is auto scaling though? AWS auto scaling, it monitors your application. So it takes a look at what's happening, and it automatically adjusts capacity to maintain steady, predictable performance at the lowest possible cost. Now, yes, it is called auto scaling, but it is not necessarily happening all that automatically. You are still providing some of the parameters and some of the things that need to happen for it to auto scale. But Amazon, like, this auto scaling has the ability to take care of this for you. Okay, auto scaling is a service inside of the EC2 service. So it's nested in there. That's where you got to go to get to it. We'll see that in a second. But what it does is it allows you to create these scenarios. You can there's a couple different types of scaling. There's step scaling. There's, you can scale on the percentage of CPU usage that a system is using. You can say, hey, when my server is at 80% capacity or above, when the CPU has 80% utilization or above for a duration of 5 minutes, let's say, go ahead and scale out one. Go ahead and give me one more server. Okay, and so your auto scaling group, these are called auto scaling groups. There's more information here about that, but these auto scaling groups will kind of take a look. Everything will take a look, and it'll say, cool, this server has been at 80% utilization for 5 minutes. I'm going to go ahead and I'm going to add another server to this pool, and it will handle the provisioning of that server automatically for you. It'll spin it up. It'll get everything ready to go as long as you set it up appropriately, and it will add it. Once it's up, it'll add it to the pool, and it will continue to monitor and say, hey, maybe your traffic is still too much, and it'll watch for that CPU usage and it'll say, hey, we need another server, and it will, add onto another server. And maybe you have a rule in there that says, hey, once we're at 3 servers and maybe we're still at 80% usage for 10 minutes, then go ahead and scale up now. And instead of having a new additional resource, it will create a larger server. It'll take those T2 mediums you have, and it will give you a T2 large, and it will create a T2 large, and it will add that to the pool and pull one of your smaller ones out of the pool, and do the same thing to the other two, and it'll give you larger servers and pull the smaller ones out of the pool. So now you have more processing powers, but the same amount of servers. And so you set the conditions for this to happen, but Amazon handles the scaling of that automatically. It handles the application of those rules automatically for you. It is phenomenal. I'm not joking with you. Again, I at the beginning of when the pandemic started, I was helping lead I was leading the digital footprint for the Small Business Administration. The Small Business Administration in the United States is the one who's helping the businesses get their money and stuff. So it was a big deal. So businesses, when everything was getting shut down, were like, hey, who's gonna help us? The government said, hey, we have money for you. So everyone's coming to the Small Business Administration website, and auto scaling saved our butts big time. Well, there were a bunch of things that we implemented to save our butts because we were getting absurd amounts of requests constantly all day. But auto scaling made it super easy to say, cool, we know we're getting tons of traffic. Let's create our policies to be able to respond accordingly for the things that we do have on servers. And it handles all that for you. We would just watch. You would watch it at much more of a macro level. Your application watching becomes, I'm never checking the CPU of an individual server. We're kind of watching the entirety of it rather than that. PPP saved my butt big time. G Billingsley, I as a business owner, I'm super proud of PPP. If you all knew, it wasn't the most smooth experience, but we were literally receiving information about PPP. This is how the government's wild, y'all. The government's wild. We were literally getting information about the PPP, what was going on with it, from press conferences. Watching President Trump on press conferences is how we were finding out what we needed to do. Like literally, it was like, cool, we're releasing this money, and it's gonna be, it's gonna be released in 2 days. When things like that happen, there are legal things like in place that says, hey, you got to have something to be able to process this stuff up in literal like the 3 days. And so if you all knew how small the team was who created all the things that allowed that to happen, I mean, it was nuts. It was absolutely out of control. But the tools that Amazon had allowed a very small team of people to be able to respond to lots of things. I hope one day they write a little case study on it, on like kind of what happened and what the speed in which we were able to move. Again, not perfect, but I'm talking about we were building full-blown applications, like serverless applications that did a bunch of stuff. We did so many prototypes like in like hours. Like it was crazy. Like it was pretty nuts, but it was fun though. I learned a lot about that process. It was pretty cool. Does auto scaling cause applications to go down since scaling to bigger or smaller servers, or does it stay up during the scaling? Good question, Uber King Kong. It stays up during the sessions. It does a little bit of what's called like a blue-green deployment. It spins up. It will spin up a bigger resource next. Let's say your first idea was to scale up. It wouldn't just shut your service down and spin up a new one. Well, there are ways you can have it do that. You actually can set it up to do that. But you can also have it the way that you want to do it is to spin up a resource right next to the old one. So we got a T2 medium and it's struggling. We're gonna spin up a T2 large right next to it. Then all we're gonna do is take the traffic and start to route it over to the other one, and then deprovision this one so that there is not a break in the service. But it's a good question. It can happen. It can happen to where your service does cut out, but there are things you can do in the auto scaling settings to make sure that doesn't happen. So to utilize auto scaling, that will require additional customish tooling to do stuff on the auto created instances. Yeah. You can give kind of an example of what the tool chain would look like. Say you're running a web server and wanted to do this dynamically scale. Is that all possible to do purely with AWS, configuring AWS services? Yes. You don't need any external tooling. And that is what this is right here. Launch configuration. Okay. Auto scaling group, launch configurations is what's going to allow that. So you might say, okay, I have an application might have a server may have 9 different services running on it to be able to serve your application. Okay. It might have so many different things to be able to run your application, all running and get set up. Amazon giving you a new server, how is it gonna replicate what you set up? How is it going to make a copy of your application to make sure things are set up accordingly? This again is also up to you. It all happens inside of AWS, but these launch configurations are going to allow you to create a template of what a system should look like when it is spun up, what services are on it. So a lot of this comes down to you building that AMI. Remember we talked about an Amazon machine image. So a lot of what you're gonna do is gonna be building your own custom based Amazon machine image. Maybe like if you are doing special things, that might be what you want to do. Otherwise, there are other paradigms. There are init scripts that there are user there are user scripts and init scripts that will run when a system is spun up. So a lot of times, if people's setup is fairly simple, it could be as simple as, hey, in this launch template, we are going to put a little script in there that's going to download Nginx and configure it properly, and maybe download our application from GitHub somewhere and put it in the right folder. And it'll run that script as soon as the server gets spun up, and it'll configure the service accordingly. You could use outside tooling. Some people do use Chef or Puppet and have it automatically check in. It gets provisioned, it checks in, gets all configured accordingly, great. But you do not need any outside tools. You can use all of AWS's tooling in these launch configurations to set up a template for your server and what it does when it gets spun up and what it needs on it when it gets spun up. It's fairly simple to do, but again, the best use case for this is if you're utilizing Amazon's machine images. Makes it a lot easier. I'm a big fan of having my own AMI that's got things that I need on it, because then you don't have to worry about as many outside factors, to be honest, such as weird like mirrors and things being down that you're not ready for. And so yes, it can be, yes, your AMI can be a snapshot like a VM. Yes, you can take a snapshot of a running EC2 instance. So you could, if you didn't know how to do any of this and you're like, I don't really know what to do, you could manually set up your own EC2 instance by hand, get all the applications and things configured. You could take a backup, you can take a snapshot on EBS, and you can create an image based on that snapshot and backup. And you can use that image to deploy any number of servers that you want. And so yes, just like that. And so having your own good base image like that snapshot is super helpful when you're trying to do auto scaling like this. Gets everything set up, and that template tells Amazon how to set up your server so that when it gives you new ones, it's all set up and ready to go for you. They handle all the networking and all other stuff. But yeah, what's up, Vinegard? Good to see you. How you doing today? So we're not gonna set up our own auto scaling group today, but I'll give you information on where you can look to kind of follow along with one. We have set up ones in the past, so I can also link you the videos where we did set up an auto scaling group. But what we are about to do is we're going to log into Amazon, and we're going to set up a load balancer and see if we can kind of see it in action and show you what that kind of looks like, and talk a little bit more deeply about it, because again, it's a good concept for the cloud. Console.amazon.com. So if you want to follow along, feel free to head over to your account, get logged in. Let me get my auth code going. Let's see. We won't add mobile number now. All right, not feeling the best also, but didn't fail on one of my interviews today. Hey, I'm sorry that you're not feeling the best. Completely understand. Make sure you take care of yourself. Make sure you take some time to get yourself, if you're feeling weird, like you need some vitamin C, make sure you go get some vitamin C. You need some rest, listen to your body, listen to your minds, make sure you're taking care of yourself. So I hope you feel better soon, but also congratulations on not failing one of your interviews today. Amazing. I keep the energy up. That's what I'm saying. Get yourself together so you can have the energy going into the next rounds, because we know you're going to get the call back, and you're going to get to, really show how great you are. And they're going to be like, we need you. We need you to come work for us. And then you'll be rich. That's how it happens. People say they need you, then you're rich. That's exactly how it works. But good luck. We got your back. Let us know how everything goes for sure. Update, job interviewing well. Excellent. This is phenomenal. This is amazing. Job interviews are going well out here. This is exactly what I like to hear. People, I also heard somebody, one of my good friends today, they were actually getting into, we kind of encouraged her to get into Scrum Mastering, and she took some time, went and got a Scrum Master cert, and has been like looking to get a Scrum Master role, and she was able to do that, and it's super hyped about it. It's pretty cool. I love to hear all this progress and people excelling out here and just being great. We're all just being great together. I love it. It makes me super happy. Oh, I'm not going to round two. That's I did but didn't part. Okay, that's okay. That's definitely confusing, but okay. Again, always learning opportunity. All good. That is very confusing though. I gave y'all a couple of my rants about my interviews and stuff where it was very confusing, but hey, learn from it if you can. Hopefully there's something you can take away from it. Head into the next one with some confidence. Feeling really behind on the course. It's tough to do all three with a 40-hour week job. 100% because I'm also glad that you we're able to say that out loud. 100%. All these concepts together are super tough to learn. What I will tell you is don't so much focus on making sure you're caught up and that you understand everything that we did throughout the week. Even if even if you did zero, if you're here and you're watching and you're listening, even if you didn't do any of the work, any of the assignments, and didn't try to commit much of it to memory, you would still at the end, just through osmosis, just through listening, you would end up getting a lot more of the concepts than you know. You don't have to pick it all up now at all. Do not stress yourself out about that. You know, if it's like, hey, we went over a bunch of stuff today, maybe I only got one of the 6 concepts we went over. That is, you are now farther along than you were before. And again, understanding them conceptually will allow you to move forward much easier in the future. But again, if you're not getting it all, it's okay. I had to hear, there's some things that I've heard 20 times and I still don't understand or know nothing about. It's okay. It's completely okay. All right, you scored. Oh my gosh, there we go. Rusty, phenomenal. A DevOps internship. That's what I like to hear. That's really what I like to hear. I would like to hear also, if you wouldn't mind sharing, maybe not here if you want to share privately, if you're willing to, I would like to know what company that is. And that's more so, not so that I can hassle them or anything, but I found a few companies who are offering DevOps internships or apprenticeships, and it's starting to become much more of a thing. And I'm really starting to try to find out how companies are building these things, and because I really want to start advocating with other companies and helping other companies to be able to set up these DevOps internships and stuff. So yeah, I would like to possibly reach out to them in that fashion. Just, hey, I love what you're doing with this, and really want to encourage other companies to be able to offer this. But you know, oh, it's a Pluralsight, amazing, phenomenal. Oh, this is great. This is amazing. This is see, we're a part of the you all are part of the Who You Know crowd now. That's amazing. I love the connection. My heart is warm. I love it. Congratulations. Let us know, seriously, let us know how it goes. Definitely want to hear your thoughts and the things that you're seeing. That's pretty dope. That's phenomenal. Y'all got my heart full. I love it. I really do. Making moves, making waves. Amazing. All right, so let's go ahead really quick and let's try to set up a load balancer really fast. So what we're gonna do first, I'm gonna go into EC2, all right? And the first thing I'm gonna do is, by default, we're not, again, remember what we're doing. We're not setting up auto scaling or anything right now. What we are doing is setting up load balancers. And if we're setting up a load balancer, the load balancer needs targets. It needs some servers in the pool. So what we're gonna do really quick is we are going to spin up 2 servers super fast that we can use to make work. Or let's do 3. Why not? We can spin up as many as we want. Let's spin up 3. We will delete these at the end of the session. If you still have free tier money, this will not cost you a thing. It's not a big deal. So we're gonna use the free tier. I'll make them all Ubuntu. That's fine. So I'm gonna click brand new one. I'm gonna click select for Ubuntu. We're gonna keep it very simple. We're gonna keep it T2 micro, we don't need anything crazy here. Keep it free tier eligible. Instance details, I'm gonna keep everything default. I don't need to do anything crazy here. Add storage. We can leave it on 8 gigs because I don't care. You can put it up to 30 if you want to keep these around. We are not keeping these around at all. Add tags. I'm not gonna add any tags now. I'm gonna add tags afterwards. Security group. Oh, these are going to be web servers. So I'm going to select an existing security group. And I think ours last time was 11, maybe. No, 10. Cool, 10. I'll use security group 10. No. What? Which one had okay, yeah, it is security group 11. That was weird. That's port 80 open. If you don't have one that already exists, you might have to just use the security group that you have. But remember, you're gonna have to open up port 80 in the security groups. You just gotta click on it and go in there and change it. For that, how do you know what settings to put in? So that's a good question. That's a really good question that has a couple of different layers to it. The by default, Amazon's error on the it's erring on the side of you don't know all of the things, and so by default you can use the settings that are already there because it'll give you the things necessary for your server to be able to receive internet connections from the internet and to be able to send information out over the internet. By default, it'll give you everything that you need, minus the security group piece. Okay, if you need other things, if you need to be able to configure certain things like specific things about the network, the way that the resources are set up, it does have it. That's what those options are for. But by default, you don't need to do that. Those are things that you'll learn over time with the way that you're going to be hosting your system. So yes, if you still have one that you spun up last week, you can absolutely use that. I'll show you how to put it in the pool. Yes, you can use that one, but you might want to right click it, and I think you can go to like add more instances like this or something. You want at least 2 servers here to use a load balancer. One, you can do it fine with one, but so that we can actually see it in action, 2 servers is what we're gonna need. I'm gonna do 3, just because, but yeah. I tried EC2 instance. Could you explain what security group is? Prop. Security group is it's a virtual firewall that allows connections through to it. So right now, by default, the only hole that's going to be open in that firewall is going to be port 22. So these ports are just lanes of communication. So the lane 22 is going to be open by default. That's going to be the lane that's going to allow you to log in to the server. But for people to make requests over the internet, web servers traditionally and by default run on port 80 and on port 443. So in our security group, for us to be able to serve that information out to the public and for people to be able to access that on the server, we must poke a hole in the firewall at port 80, and that's what this is right here. And so maybe I'll do. I'll use a brand new security group so I can show you how to do that really quick, just as a refresher. By default, this is how the security group will come. Make sure you add a rule right here. So you click add rule, and you can go to the service in here, which is HTTP, which is on the list. You got to find it, and that defaults to port 80, and that'll set up everything that you want to set up. All right, and we can do that. Sorry again. How can we create 2 more instances from the one that we created last week? You can. I'll try to show you in a second. You should be able to right click it, and there might be one thing that says like spin up more instances like this or more instances like this or something. I'll show you in a second. So we'll launch and review, but I actually want 3 of these. So let me go back to maybe I can do this in the front. There's a way to easily spin up multiple. Here we go. On number 3, if you click back on number 3, you can get more than 1. So I'm gonna get 3 right here instead of 1. I'm gonna go to review and I'm gonna launch it. Now, you know what? I need to check. I don't even know. I don't remember where we put this key pair. Let me make sure I have my key pair first. 1 second. Root at what's that? Sandbox dot mastermind dot. I typed that in right. That was a long password. So I use the Ubuntu AMI, the Ubuntu 20.04 AMI. You can use whatever you can use whatever you want. Even if you want to use Amazon Linux, you might have to just use yum instead of apt-get. But yeah, see the AWS keys. Mastermind prod 0707. That doesn't seem right. That doesn't seem like. Okay, we'll use that. That's the one that we created, I think. Okay, so make sure that if you already created a key pair, make sure you have access to the key pair that's in the box. If not, if you're like, hey, I don't know where this is on my computer anymore, make sure you click create new key pair and download that, because remember, to log into an EC2 instance, you must have this key pair. It's SSH key authentication. You can't log in with a username and password. This is the only way that you can get in. So I'm going to launch all 3 of those instances. And doing without key, yeah, you can't do without key. Okay, I'm gonna have to not to do this at work, I think. But yeah, yep. Don't. Also, again, don't necessarily. I don't think it's. If you can't follow along perfectly with this, it's not a huge. It's really not a huge deal. I just kind of want you to see. It's more so. It's more. Even if you have one server set up, that's completely fine. If you have any server already set up, that's completely okay. The thing I want you to see is how we're actually setting up because you can go back and watch the last week's video to see how to like launch an instance and get all that stuff set up if you want to know how to do that stuff. But the AWS piece of this is going to be setting up the load balancer, and the settings in there and things like that are going to be a little bit more important, which you should be able to have perfect access to. So first, I'm going to go back to my EC2 dashboard because I'm going to give these names, because right now they by default come without any names. But if you want to spin up more, I think if you right click, and yeah, I think you just go to launch instances, and I think it'll give you one. I think it'll start to maybe not. I thought it would fill in. I thought it would fill in stuff. It used to have a thing in here that was like launch more instances like this. That's interesting. Why do they? Okay, I don't know why they changed it to that. Maybe it's in image and templates. Launch more like this. So images and templates down here, launch more like this. Will allow you to launch more. See, and it takes you straight to the review screen, and all you got to do is click launch. So it'll launch basically copies of this thing. Okay. Oh shoot, that was dumb. Let's get back over there. All right, so here we go. We are going to create our first load balancer. And like I said, load balancing itself, a load balancer is not an AWS specific thing. AWS has its own implementation of load balancers, but you could take one of these instances right here and create an instance on your own. Create a load balancer on your own using Apache or using Nginx or something like that. And so I'm gonna give these some names really quick. I'm gonna call it Web 1, just so we can identify them a little bit better. Web 2, and again, these naming conventions don't do anything. They're just for our own like visual sake. And if we were doing any kind of management of them, it would be easier to just identify them. So we have 3 servers. I'm gonna wait to log into them. I'm actually gonna go first. No, actually we need to log into them first, because if we set up the reason why we need to log into them first and get them set up as web servers is because if we do not, what will happen is when we set up the auto scaling group, not the auto scaling group, when we set up the load balancing pool, we will set up them as targets, they'll fail the health checks and they'll never get activated into the pool. So we need to make sure they're ready to go first. Let's go ahead and get logged into at least one of them. And I'm gonna get logged into all 3. And so what we need to do is we need to grab the public IP or public DNS address that you can get, just highlight it. You'll select the little checkbox here, and then you can select, an IP address or something for this public DNS address. I'm gonna go ahead, I'm gonna get logged into the system. So I'll make this larger. Whoops. And we'll SSH. And remember, so SSH-I. So we need to specify our identity file, our SSH key. We're using SSH keys to log in, and we'll do this. Are these VODs somewhere where I can watch on my own time? Yes. ! YouTube. Both weeks of this are up on YouTube, and you can get them there. There's a playlist. There's a Horizons playlist on my YouTube channel that you can grab them from. Yeah, and they'll always go up there. And the user, so SSH-I to specify the key that you want to use. So this is the one that I selected. All right, so it's going to use that SSH key to attempt to authenticate with the server. The user, because I used the Ubuntu image, needs to be Ubuntu and then paste in the address. Yes, this is what I would have worked today. Remember, there's benefits. Well, one, it wouldn't have mattered anyway. Even where I worked before, it's been completely fine. But I work for my, I'm my own boss. So yes, I did wear this into the office. Mostly, remember I told you on the beginning that I don't love this shirt because I like the way it looks, but I don't like the way it doesn't stretch at all. But yeah, it doesn't stretch at all. So I don't love that. And so I generally only wear it when your boy needs to do some laundry. So, just give you a little insight into I need to do laundry like now, like bad. But I've been trying to get the house together and for the baby, and I've been trying to make business work. So we'll get to it. I'll be honest with y'all. We're all living our lives, so I gotta get it. I love it. Aaron and the Tale of the legend, the laundry dashiki. I thought it said legendary. It's the legendary laundry dashiki. Also, it has pockets. You can't see it, but like I have my hands in my pocket right now. Like I like that. Kind of weird to have pockets in the front, and 2 of them at that. So, you know, it's kind of nice. I look really weird when I walk around with my hands in my pocket like that, but it's comforting. All right. So this is how we're going to log in. I'm going to type in yes. And what do we need to do first? Let's do a sudo apt update and sudo apt install nginx. All right, so I'm gonna paste in this command for you so that you can just copy this and paste it into each of your servers to make sure nginx is installed. If you're using the server that you already spun up last time, nginx is already there and it's already ready. Okay. Yes, there we go. Add typist. Thank you. Install, and so update and install. So what it's going to do, I don't know if you all remember in the Linux stuff we talked about, we did a little bit of Linux stuff. I'm not sure we showed you the ampersands. It's going to run this first command. The first command is going to update all of the it's going to update the repositories and stuff that it has. It's going to update all of its sources and things to know what's available to it first. And so this is something that's common to do when you first spin up a system. And after you do that, it's going to run this ampersands, which says, hey, let me chain two commands together. As long as the first one finishes successfully, I'm going to run the second one. And so then it's going to run this command that's going to install nginx for us, and we're going to be good to go. So I'll copy this. I'll paste it in the chat. Yes, so the double ampersands works on anything. It says it allows you to run two commands, and it only runs the second command. It only runs the command on the right if the command on the left passed successfully. So that's what, so it just allows you to run two different commands from the command line in one line. So that's the command that you would run. So I'm going to run this, and it's going to go through and it's going to get the web server nginx installed for me. While this is happening, I'm going to go ahead and I'm going to get logged into the other two servers and do the exact same thing here. Okay. So you're logged into that one. Cool. No, I don't want to do that. That's an logical operator that will only run the second. Yep. You got it. You got it. Let me get into the other two servers. So I'm going to grab the IP address of this one and get logged in here. And I'm going to run that update and install command really quick there. And let me get logged into the final one here. It just sucks because I'm doing like a triple SSH, well, double SSH. So I'm logging into my Linode server, and then I'm logging into from my Linode server to the other servers because that's the one that has the key on it. So that's the only reason it's taking me this long to get logged into all of them. And let's copy this address and log in. Oh, wait, that didn't work. I didn't get logged in. CD, AWS keys. And all right, here we go. So it's done on 1, it's done on 3, on 2, and it's still running on 3. So what exactly is cloud computing? That's similar like commanding a supercomputer to do a certain task. No, it's not. I know it. That's what's interesting. It does sound. It sounds like that's what it would be. But all cloud computing is networked computing resources that you can gain access to on demand. That's all it is. So it's literally it's computers that are networked together that you pay for access to. That's all the cloud is. That's really all it is. It's networked computers that you pay to log into. That is, well, you're really paying for the resources and to use the resources, but it's really, it's not anything fancy. They've done a great job at making it sound like something crazy. And so it's really just a bunch of software, and it allows you to basically rent pieces of Amazon's computers. It allows you to use some of their CPU and some of their RAM and some of their storage space as you wish in a bunch of different ways. They give you a bunch of different ways to interact with it, but that's all you're doing is you're renting someone else's computer. You're paying for so paying for a server at a data center, yes, 100%. But with what is done and what makes it seem so complicated is that's one way to do things, and that's valuable. Yes, renting a server, that's what we just did. Was we rented 3 servers from Amazon, 3 virtualized servers. We rented that from Amazon. But there are almost 200 services in Amazon, and they break up the way that you can use a server in different ways. Maybe I want to just run a database. I don't really care about the server. I don't really even know how to manage the server and stuff, but I want to build an application and I want a database. And so what Amazon will do is provide software over top of that and allow you to rent a database. You rent access to a database, and they'll handle all the underlying ways that their servers are utilized. But to you, you're renting basically CPU capacity and storage from them, and network throughput from them. But they've given you a little software over top of it to interact a little more easily. And so it gets a little bit weird, but you really are just renting computing resources from a service provider. Cloud native simply means an application that was designed to run in the cloud paradigm. So in the distributed nature of the cloud. So we are going to talk about distributed computing and kind of really understanding what that means and what that is. And cloud native just means an application that's designed to utilize the features of the cloud, the services that exist inside the cloud by default. Applications that are not cloud native, when you make a shift to moving them to the cloud, oftentimes you have to re-architect the way things work in them so that they work better with the paradigm of renting these different services from a cloud provider. That's all that is. What's up, Famomo? How are you doing? Wouldn't it be cheaper to build a decent computer yourself? No. No. It wouldn't. So there's a cost. Cost is an interesting thing. The cloud is not cheaper. Let me tell you that right now. The cloud is not always cheap. It's cheaper for larger organizations, and it's also cheaper for. There's like a big it's a big parabola. And so it's cheaper for people like me and you who just want to mess around. It's not cheaper. It's more expensive for us to do this way. But what it does is it gives you access to the power of what Amazon has. So right now in my house, I could build infrastructure right now and honestly in minutes that could serve millions of people right now very easily. That kind of cost can only pay for what I use, and maybe I can spin it out. Maybe I have something that's going to go out that people are going to utilize for 20 minutes. I can spin up enough, pay for what I use, and spin it down. If I were to purchase or build the amount of computing power that I needed to do something like that, it would set me back tens and tens, if not hundreds of thousands of dollars up front. So it is not. It depends on your use case for sure. When people say, "Oh, the cloud's cheaper," the cloud is not cheap. It can be. It absolutely can be cheaper if you utilize the pieces in the right way. Remember, the cloud is just a bunch of Lego pieces. It's just a bunch of Lego pieces that you can put together, you can stack up to build a solution. And if you rent the right services and know how to configure them properly, you could save money. But there's a lot that goes into deciding whether or not that makes sense. Like buying from Safeway versus buying from Costco. Yeah, I mean, it's kind of like that in the long run. In the long run, maybe a lot of people don't take into account things like the network bandwidth, things that you get from stuff like this. The kind of pipe that you would need to be able to serve that many people. Like, it will cost you so much to be able to pay for that. So it's pretty. It can get weird when you really dive into the true cost of what they're giving you. $5 US per month is way cheaper than building a full computer, right? Yeah, I mean, it could be. I mean, it is cheaper, but how much power are you getting for that $5? There's a lot of things that factor into it for sure. Cloud gives you redundancy, environmental controls. It gives you power. Like, the cloud gives you an immense amount of power at your fingertips, and that's really important to organizations who, again, if I'm a shoe company and somehow we end up on Ellen and now everyone's going to my site. Making sure that my site doesn't go down might make or break my company, to be honest. Like, making sure it can serve that is pretty darn important. Static S3 sites are probably the most cost effective. Yes, both of my sites are static. I pay for those. I pay almost nothing. Even serverless applications. There's a bunch of stuff that can make you can build robust applications for dollars and run them to tens of thousands of people for dollars per month if you do it right. It's awesome that I have that power at my fingertips and I can stop when I no longer need them. The Alt F4 stream. I'm gonna get the shout out right the first time here. Welcome to the channel. Thank you so much for coming in hot with the raid right when we are we're finally getting hands on what we're doing tonight. Welcome. Let me give you the correct shout out the first time because I typed in SO this time. Welcome. Good to have you. Appreciate you coming through. I hope you had a great stream. I saw you were doing building stuff with Go. I was in there for like 5 minutes because I got home literally 10 minutes before I had to stream today, doing finishing up some projects. But welcome everyone. Please go follow the Alt F4 stream if you want you get all kinds of stuff over there. You see he's building really dope things. There's also a Toto on there who's learning how to code. So if you're trying to go on the same coding journey as someone else, a Toto's on there learning how to code. Some days they play games over there. It's a very exciting place to be. Definitely give them a follow if you want to have a little bit more fun on Twitch. But for everyone who just came in, welcome. What we are doing right now is we're diving into some AWS concepts tonight. Right now, we just learned about scalability and elasticity and auto scaling and things. All we're doing is setting up a load balancer really quick in Amazon before we move on. We just kind of want to get hands on with some of the services. We just spun up 3 servers. Oh no, you couldn't hear anything? Well, I'm sorry about that. I'm not repeating myself, but welcome. It's good to have you. Just, as usual, just telling everybody to go follow your stream so they can learn a bunch of stuff, build a bunch of cool things, have a lot of fun with you and a Tota. That's all, that's all I said. But we just got, like I said, we just spun up 3 servers because what we're going to do is set up a load balancer really quick in Amazon. We're going to set up a simple classic load balancer. The concept is bigger than the implementation right now. We're going to set up a simple one really fast here. So we just spun up 3 different web servers. We just installed Nginx on all 3 of them. How can we check if Nginx is installed? Service, Nginx, status, or system CTL Nginx, or status Nginx, whatever you want to do. However you wanted to check that out, you can do that. Thank you so much for the tier 1 sub. I really appreciate the love, man. Thank you so much. Sorry, his message was UDP. 100%. We talked about that a little bit. Y'all see, the packets didn't go through. They were missing. UDP don't care. They didn't care at all. It just dropped them. They don't care. It just kept going, but it came through quick. Okay. So we do have Nginx running, and what we can do is to confirm that we have some web pages up and running. We can grab this public DNS or public IP address, and we can copy it and put it in our browser and see. Check that out. Welcome to Nginx. We have 3 working web servers just like that. But what we're going to do really quick to make them identifiable is really fast. I'm going to go in and I'm going to change the default page so that you can identify them better. I'm going to call one web server 1, one web server 2, one web server 3. So let me go there. The default page is in var www HTML. And there's this file here. I should have them installed. If I don't, because it's a new build, I'm going to change it to just web 1. Whoa, oh, I can't change it. Hold on. You have to sudo vim it. So you don't necessarily need to go through with this piece at all. I'm just editing this file. Editing in Linux is a whole different thing. If you're like, bro, I'm having trouble following, it's okay. The goal, I'm only doing this right now. This is not something that you have to do to set this up. It's just simply going to make it easier for your eyes to see what's happening. And so all I'm going to do is change this to, instead of saying, welcome to Nginx, I'm going to change this one to web 1. Okay. And I will change this one to web 2. Var www HTML. We'll change this to web 2. And we will change this one to web 3. Pretty simple. It'll make it super identifiable when we are going through the load balancer. Okay, that's the only reason I'm changing this. This is not something you need for implementation. I just want to make it so that when we go to this Welcome Nginx page, we know which server we are hitting. Oh, well, I messed that one up. I meant to be changing the title, but I said I changed the metadata piece that's going to set the title of the window. That's cool. That's not a big deal. It'll still show us visually what's happening right there. All right. You know, see, I wasn't even paying attention. This is why you pay attention to what you're doing. I meant to change this line rather than that line. I could easily just go in and change it, but no, I'm not gonna do that. You know, I'm gonna stick with my, I made a mistake. I'm gonna learn to live with it. All right, so now let's actually get to the part where we are setting up our load balancer. Let's go over to the left here. Load balancing exists inside of EC2, and we can go down to the load balancing section, and we get, there's two options down here: load balancers and target groups. Okay, load balancer is what we want to begin setting these things up. So I'm gonna click load balancer, and let's get ready to go. So these are old in here. These are really old. I actually don't use either one of these. And I think one of these load balancers has an ASG with it that's causing me a bunch of problems. But yeah, the target groups, remember we talked about the server pools, the pool of resources that the load balancer can send data to or send requests to. Target groups are basically what Amazon calls those pools. It calls them target groups. So it's the target for the load balancer. It's a group of servers that's a target for the load balancer. So we're gonna create a brand new load balancer. And oh, okay, I'm about to say I was about to be very upset. And not for any other reason than Amazon offers a couple of different types of load balancers, and we're about to talk about these right now. This is important. We're learning about Amazon. You should be familiar with these. There are a couple different types. Application load balancers are amazing. Application load balancers are pretty intelligent load balancers that are able to properly balance and handle HTTP and HTTPS traffic. They operate on, application load balancers. If I said networking, I'm going to say application load balancers. I'm talking about this one over here. What they do is allow you to be able to, again, route these requests at the application level. Layer 7 of the OSI model, if you are familiar with the OSI model. If you're not, it's okay. Remember, we said at the beginning of this course, write it down. Write down OSI model. I can also share an OSI model in the Google Classroom for you as well if you need it. But it operates on layer 7, the application layer of the OSI model. It's pretty smart too. And it allows you to get granular with your request routing, and it's pretty cool. It's a pretty dope thing. But we're not going to dive into that today because there are a few more topics that you would need to do to understand that. If you are trying to get any of the exams, it might ask you any kind of application load balancer stuff. It might basically ask you like which load balancer will be best for routing. You know, you have a complex web application that needs to route HTTP and HTTPS traffic. Maybe it'll ask something like that, and the answer would be application load balancer. That's why. So this is the one that you're probably going to use the most in the future. A lot of people are using this one down here. We're going to set up the one down here, but this is the new generation of what load balancers are in AWS. They're very smart and they're pretty cool. Network load balancers, on the other hand, are also amazing, but this is what you want to use. This works on the network layer. It works on layer 4 of the OSI model. And what it allows you to do is to, when you need very lightning quick throughput of these requests and send off of these connections, you would use a network load balancer. I'm pretty sure network load balancers are much more expensive, and the setup is a little bit different. The way that you set them up is actually completely different, and that's something that you can do. Gateway load balancer, don't worry about gateway load balancers right now. This is something, it's not super new, but it's new enough where it's something that's not really touched on any of the associate level exams, or at least hasn't been in the past. And as far as as I've seen, I haven't seen them talk about that very much. We can kind of talk about that a little bit later if we have time. And then we have this classic load balancer. This is what you might see if you've been learning AWS for a while. You might have seen the term ELB before, Elastic Load Balancer. And this is what they were referring to as an Elastic Load Balancer. And it's now the classic load balancer, and it's previous gen, but it's so popular and it's so at the heart of what a lot of people have done already in AWS. They're keeping it around. I think they have the plans to deprovision it eventually or deprecate it eventually. But right now, too many people use it. and they still ask you lots of questions about this on the exams. And it's going to be the easiest one for our use case to set up and get running. So we are going to create one of these classic load balancers, and we're just going to click create here. All right. And again, like I said, I usually set this stuff up via code, via Terraform or CloudFormation or something like that. So bear with me if I miss some, if I'm trying to figure out some settings. We're going to go through conceptually. We're trying to understand this, but we'll get it set up. So let's give it our load balancer a name. And so I'm just going to call this Horizons LB. It's so popular, lots of people still have their configuration and will complain if it's removed. That's it, 100%, 200%. That is exactly what it is. And so Amazon's always going to have this problem. They have so many people on it now. It's always going to be a problem. So give it a name, give it whatever name you want. But yeah, how do you usually set it up again? What's it called? So I usually am configuring infrastructure via code. This is something that we're going to do here in this course. It's also something that we're going to spend an entire week and a half doing in pipelines, if you're following that. But I use I've used a couple different applications for this. One is called Terraform. Terraform is a very popular tool for provisioning cloud infrastructure. If you are really serious about learning the cloud, it's absolutely something you should look into. We are going to learn a little bit about Terraform. Well, here we're going to use something called the CDK, which is the cloud development kit. Amazon has their own cloud development kit, but all these things are a way to be able to write, to be able to express via code that I want a load balancer and how it's configured. So instead of going through this process, I would say, hey, I will write some code that says, hey, I would like a load balancer that has these different configurations, and I would pass that information to Amazon's API, and it would configure that for me. That is how a lot of this stuff is done nowadays. There's nothing wrong with the console. Let me be clear. Again, I don't usually provision via the console, but I do change a lot of settings. I do a lot in the console still, but I usually don't provision via the console. What layer is the classic load balancer running on? Good question. I think classic load balancer runs also on 4. That's a good question. I think it's 4, or you might be able to set it up to run at both 4 and 7. Now that I'm thinking about it, what layer does AWS ELB run on? Let's see. Let's look it up. Application load balancers. So that's application. Great. Classic load balancers are on layer 4. Okay, layer 4. I kind of feel like you could also make it run on layer 7 as well. But yeah, 4. Cool. That's this right here. Phenomenal. And here, I'll share this with you because they have some information about these load balancer type as well. All right, so give it a name. Leave it at your default VPC. Don't worry about VPCs yet. We'll learn about VPCs. Don't change this. You probably don't have another one, so probably not a big deal. Leave it at that. Create internal load balancer. I don't want it to be an internal load balancer. This is for if you have traffic routing internally in your network to different systems and stuff. It'll configure it network wise to not have access externally. I'm going to leave that off because we want to have this how it is. We want to be able to have access to it. Enable advanced VPC configuration. Don't need that. We just need the basics right now. What we have down here is listener configuration. How is the load balancer going to listen for requests? And so the load balancer protocol and the load balancer port is going to be port 80. So right now we don't have any SSL keys or TLS keys. Not keys, certificates. SSL is not a thing anymore. But we don't have any TLS certificates. We don't have our web server set up to be able to serve on a secure port. It runs on 80 by default. When you just start up Nginx, it is running on port 80 already. And so it's going to listen on this port, and it's going to map to instance ports 80 as well. So you can leave this as is. In the future, if you're working on, if you're building one of these for a company or something, you're generally going to add also in the HTTPS protocol, which runs on 443, and probably also map this to 443 as well. But we don't have that configured, so we're not going to set that up right now. And so we don't need to change anything really. Just give it a name and click next. Assign security groups. And here is where we can assign some default security groups. We have this default VPC one. I leave it on the default VPC one, or you can give it the security group of the thing that you just created. But we can also go in and change the security group later. So that's not a big deal at all. Did you already talk about TLS certificates? Or we are not, because those are not a part of this course. They might be a part of pipelines, but they're not a part of this course because we'll talk about them in terms when we get to DNS, and when we're talking about Route 53. We're talking about we'll talk about ACM and stuff. So we'll talk about TLS certs in regards to how Amazon handles them, but we're not going to dive crazy deep into it in this one because it's mostly about AWS stuff. Peace out, Unique ID. Good to have you. What's up, Goku? How are you doing? All right, so we can select a security group. We can also change it. I'm going to put both of these here. You can leave it on the default if you'd like. And I'm going to click next. Improve your load balancer security. Your load balancer is not using any secure listener. So this is basically saying, hey, you're not using HTTPS. That's fine. I just said we don't have it set up, so we don't need to do this. But really quick, for you all wondering what SSL is and HTTPS. So the protocol to run the web, that runs the internet, is called HTTP, which stands for Hypertext Transfer Protocol. Okay, HTTPS is Hypertext Transfer Protocol Secure. So this is a secure version. What this does is this encrypts data. It encrypts data between the client and the server. Data is transferred in between. So whenever you go to a website and you see this little lock here, it says, hey, connection is secure. What this is doing is it's using a certificate that has a hash that is it's using that data to be able to encrypt that information in between. And so this is what makes it secure. The way that you do this is through these certificates. They used to be called SSL certificates. People still call them SSL certificates. SSL is actually deprecated. They are now technically TLS certificates. Don't worry about it. SSL stands for Secure Socket Layer. It gets deep. It gets a little bit deeper there, but just know that this is what keeps the website secure. Without it, when we're running over port 80, the data that's transferred between the server and the client, which is my computer, is not secure at all. Okay. And so once we do that, it's giving us a little warning, but that's no big deal. And now we're going to go to the health checks. We talked about health checks, so now we're going to get to set that up. I'd like to know that my wife just got back from her 31-week ultrasound and everything looks good, amazing. I couldn't go because of COVID. I know that's been really sucky for me as well. So that sucked, but otherwise, dope. Congratulations, first off. We are exactly the same time. My wife is now 31 weeks. She just, I think yesterday made 30. Yeah, it was her 31st, the start, or at least the start of her 31st week. She's, I don't know. I think she ended it there. I don't know. One of those two, either ended the 31st or started the 31st. But yeah, I think we're right on the same timeline. I don't know if we're getting a 31-week ultrasound. I gotta go find out. I have no idea. But that's dope. I'm pumped too. I'm pumped for you. Amazing. We can, you know, when we're both up crazy late at night, you know, we can hop in the chat, give each other a call, and be sad together that we're up in the middle of the night. Zero-based index on weeks. Okay, exactly. Yeah, I'll figure it out one day. I'll figure it out. And by the time I figure it out, the baby will be here, guaranteed. All right, but yeah, peace out. Have a good night. Go spend some time with the fam. Thanks for coming through. All right, so this is the health check. What does the health check do again? The health check says, hey, I'm gonna go ahead and determine whether or not the servers that are in this pool are healthy or not. If they are not healthy, I'm gonna pull them on out of the server pool or the target. I'm gonna pull it out as a target, but this is where we set it up. So protocol that we're gonna check over is port 80. Remember, I just said HTTP is the protocol that runs the web. This is what Nginx is being served over right now. When we request Web 2, it says not secure because we're not using port 443. There's no certificate. We are requesting this over port 80. So we're gonna leave it at ping port 80. Ping path says index.html. Change that to just slash. So the name of the file is not index.html. I don't even think that'll work. It'll give me a not found, but we just do slash. I think we can just ping slash and it'll work. So basically, it's going to try to hit the web server at slash like this, which is, you know, a path on the computer. Index.html index file is usually what the entry point file to a website is. So that's usually why it gives it to you up front, but we can just ping slash. If this doesn't work, slash should work, but if it doesn't work, we can create a file or we can give it the index file that's in there. But cool, just make a slash for now. Response timeout, okay? This is going to be how long it's going to wait for response. So it's going to attempt to connect to your system at port 80 at this ping path location. All right, it's going to wait 5 seconds for a response. If it does not receive a request in 5 seconds, it's going to determine that that's a failure, and it's going to wait. It's going to wait at least that long in between sending that failure off or whatever. The interval is how long in between checks. So it'll wait 30 seconds in between checks, but it'll only wait 5 seconds before it determines it's unsuccessful. Unhealthy threshold. Once we get 2 in a row, once we get 2 failed responses in a row, it will pull it from the pool, okay? And a healthy threshold is how many it needs to get in a row before it puts it back in. So it needs to get 10 healthy checks in a row before it puts it back in. So what we're gonna do really quick is change this interval down to 10 seconds so we can show some cool stuff. And I'll leave 5 seconds is fine. And we'll leave it on 2 and we'll make it 4 to go back in. All right, so let's go ahead now, and it says add EC2 instances. What did we just do? We created a bunch of EC2 instances. So let's add them. And all you gotta do is click these right here to add them to the target. Okay, so those are the 3 that I just created. And you can leave those here. We'll talk about those in a second. Add tags, you can give it a tag if you want. I'm not gonna give it a tag right now because we're gonna delete this. So no need to give it a tag. And go to review and create. It'll give you a little overview of the things that we selected, and go ahead and click that create button. And just like that, I now have a load balancer set up, okay? So this Horizons load balancer is in fact set up. It's gonna run some health checks here, and we can kind of see what's in it. Right now, everything's out of service, right? Because instance registration is still in process. We're just getting started. It needs to get everything configured. How are the tags useful? The tags are useful. The tags are just metadata. So the tags are useful because you might have lots and lots of services inside of Amazon. The tags allow you to be able to use this metadata for tracking, for filtering, for being able to find and discover and manage these services. It's just information that you can use to query things automatically. Yeah, it's just a little bit of extra data that you can use to identify the services or servers or whatever. So I might say something like, I might tag each service with an environment tag that says, hey, this load balancer is a part of the staging environment. So then later on, I can pull all resources that have the tag staging to determine what resources are a part of the staging environment or something like that. So you can use them for a number of things, but it's just metadata, okay? All right, so check that out. Just like that, it's in service. This is interesting. It seems like they've moved target groups out to be something different. Or does it create it automatically? This is very interesting. Actually, this is definitely changed. You used to have to create a target group for sure. Okay, no big deal. This is actually kind of nice. Actually, this is nicer. So now that these are in service, we can get the address of this load balancer. So we're still down here in the load balancer group. If I grab the DNS name, which is this right here, and if I go ahead in my browser and I paste this in, I get Nginx back. But check this out. It's coming from Web 2. If I refresh it, I got a new response coming from Web 3. Again, Web 2, Web 1, Web 3, refresh Web 2, refresh Web 1. Okay, so you can see that it is balancing the load in between them all. I think by default, this is going to be a round robin type distribution. Let's see if I can see where this is at. Stickiness disabled, so I could add for sticky sessions. But there are a bunch of different options in here that you can use. This is where Amazon gets, where it gets uncomfortable. You can't learn all the options and stuff, but you have tons of different options to how you want to check this out. Now, watch this. I'm going to break one of the servers and watch how we no longer get it anymore. So right now, we're currently getting them all. 321, 321, 321. We're getting them all. I'm going to break one really fast. So let's go ahead, and this is web 1. I'm gonna break web 1, okay? And I'm gonna do that by just simply stopping. Sudo. I'm gonna stop it like this. So Nginx is now stopped on the system, or it's stopping on the system. And so I'm gonna start refreshing, and check this out. Check how fast that happened. I'm only getting I'm refreshing a bunch. I'm only getting 3 or 2. It's pulled it out of the system. It's pulled it out. I'm not getting any errors. As far as you're concerned, as far as the user's concerned, there's been no change to the functionality in the systems that are serving this. And if I start it back up, it'll start back up. It'll go through the health check. So that health check is running every 5 seconds. And so it should take a little bit. It should take like 10 seconds because it needs to do 4 health checks. I'm gonna keep refreshing, but eventually we are going to get web 1 right back in here. What's up, Easy Life Form? Good to have you. I'm just gonna keep refreshing it a little bit. And we can also see from the management console what's in and out. So it says 1 is still out of service. Come on, get back in there. We can watch for it to get back in, and now it's back in service. So now if we start refreshing, web 1 is now back in. Yes, great question, Banu. 100%. So something has changed in the way that this is set up. And maybe it's only for application load balancers now, that you have to set up the target groups, but you used to have to do it in 2 pieces. You used to set up the load balancer, and you would set up its configuration, and you would point it at a target group, and you would have to create a target group, and then you would have to add the servers into that target group. This might be a change that specifically applies to the classic load balancer, which would be interesting to see. It didn't used to be this easy to do this. So very interesting that I could just click some buttons and add it. I have target groups, but these are for other things. These are for some of the other load balancers that I have set up, but very interesting. But the target group, if you want to go through and see it, you can list it. You can create it, says, hey, I want to add instances to this, and you give it a name and stuff, and then you provide the health checks here, and the target group handles those things, and you attach the target group to the load balancer. I'm actually not sure what changed in here, to be honest. That's very interesting. I've never not set up a load balancer without setting up a target group to attach it to, so this is very interesting. This is definitely a new interface. This is definitely a new, the thing to create it is pretty interesting. So when you host your site, everyone is directed to the load balancer. Yes. So 100%. So when you set up DNS, so when you set up the system to where, let's say you had a domain, let's say your domain was horizons.com, and you wanted to point everyone at this cluster of servers, you would make the DNS point to this address, to the address that the load balancer has. You would point everything here, and that would handle everything else. So none of my new instances are resolving by public DNS name. Am I missing something? Did you actually start Nginx? What are you seeing? So if Nginx is not running, like if we stop Nginx on all of them, it's gonna pull everything. It's gonna pull everything. Let me grab the public DNS from this really quick. Of web 1, which I'm assuming we did in order. You will hold on. Yeah, so if it's not running, you'll get this. If it's not running, you'll get this. If great, perfect. That's all I was going to go to next. Nitro Sage. If you did not change the security group to allow for port 80, then it will actually just, I think it'll just like time out and say it'll be something like this, but I think it'll be a little bit different. But yeah, it's likely auto scaling group. So the way that you can check this easily is if you go down to load balancers, just getting the page back when I hit the DNS name, just not getting it back. If you click back on your load balancer, and you go to I've actually never even seen this page before. This is actually it's so new to me. It's interesting. Whoops. I'm sure security groups is right. Yeah. So if you go to your load balancers, highlight your load balancer, go down here to security group, and make sure whatever your security group you have, so you might only have one, make sure that it is allowing port 80. Make sure that port 80 is allowed in the security. Yeah. Yep. There we go. Yep. You go in there and change that, and it'll be good. AWS changes so fast. Oh, the new roof. Oh, see, that hurts my heart actually. No, is it that different? I have to look at it real quick. I have to see. But you know what? Nah, I mean, I'll wait. I don't want to be sad right now. I don't want to be sad. Let's just go back to what we were doing. Cool. So we have a load balancer. It's up and running. It is serving traffic between the three. There are a bunch of options in there, but you can see that it was actually pretty easy to set that up. The manual setup of a load balancer is also not super hard. To be honest, it's some configuration in Nginx, but it's kind of weird. So change the port. When I had instances, was allowing port 80 and it worked, but the DNS name is timing out, but the instances are working. That's interesting. That's very interesting. Okay, so that's a load balancer. At the end of the day, again, I want you to understand the concept of a load balancer. We set one up. I'm not going to delete the load balancer, but I'm going to delete the actually I am going to delete the load balancer so that I'm not charged for these things, because I'll forget about them and I'll leave them running. And my bill is already kind of expensive because I'm doing some dumb stuff in here for good reasons, though. Dumb stuff for good reasons. So I'm going to delete these now. This is one of the things that I love about AWS as well. I can simply delete. Let me make sure I'm not deleting. Okay, cool. That one server I need. Yeah, check the security group for the load balancer for sure. Manage instance state, instance settings right here. I'll terminate them all. Get on out of here. I'll get rid of this load balancer as well, just so I'm not worried about it in the future. Now, you know, should we refresh the page that was hitting the load balancer? Actually, I don't even have it anymore. We try to hit this, it will, oh, it's actually still up and available. Ah, there we go. It's down now. It's definitely down now. All right, so that's the load balancer. Let's keep moving so we can get through all the S3 stuff. So what I want you to get out of this is, when you are talking about dealing with scaling and we're talking about servers, this is one way. This is all of this scaling that we're talking about is conceptually scaling and elasticity and stuff, but we're talking about this specifically with compute resources and specifically inside of EC2. This is all the things that we just did are they're about EC2 auto scaling groups. That is about scaling EC2 instances and scaling those things out and up. And the load balancing is balancing load in between those things. The other types of load balancers can balance load elsewhere as well, but most of this is primarily focused around EC2. That is why it is in the EC2 section of the setup, but very important concepts. Now, EC2, like we said, is the backbone of AWS. It really is. But simple storage service might be their most utilized. It might be their biggest service in a sense. All right. And so simple storage service and static web hosting. We'll talk about both of these things because the static web hosting is a surprisingly immediately applicable piece of what S3 is used for. And you might be saying, you know, what does simple storage service have to do with web hosting? Well, we will see. Keep it simple, smarty. We don't do keep it simple, stupid over here because we are all incredibly smart, because we're just smart. We're not stupid. Okay, so let's talk about S3. And seriously, this is a powerful and pretty it's interesting because it is simple in comparison to a lot of other services, but it's both powerful and pretty versatile in what it is. And so it's pretty interesting how this works. So definitely pay attention to this piece. I think we'll have enough time to get through everything in the next hour. I think we're right on time. So what is S3? Another one of those weird naming conventions. We got EC2, which was Elastic Compute Cloud. And now we are on S3. So Amazon Simple Storage Service. Amazon S3. So 3 S's, okay? Simple Storage Service. It's a scalable. So remember, scaling up and down. It scales. You don't have to worry about the scale here. This is the benefit of some of their services. It's a scalable, high-speed, web-based cloud storage service designed for online backup and archiving of data and applications on Amazon Web Services. Okay, it's scalable, high-speed, web-based. These are all 3 really important attributes of what this is. But it is a storage service. Think Dropbox. Dropbox was originally built on top of this, but it's a storage service for Amazon Web Services, or inside of Amazon Web Services, not just for Amazon Web Services, but inside of Amazon Web Services. And you might say, okay, storage, that sounds fun. And yeah, it's fun. Sure, that's great, but it has a lot of amazing features and a lot of other things that it can do. So why is S3 so revered? Why is it so important? Why is it so great? Well, the reason is because it's easy on your wallet, kind of, a little bit. It's pretty cheap. It is, in fact, pretty cheap for storage. And we're gonna get a little deeper into the type of storage. Remember, we talked about the different type of computing resources, and we talked about storage being one of them. This is persistent storage for one, so this isn't like RAM. It's not volatile. Can't cut it off. It is persistent storage, but it's also object storage, and we're gonna talk about that in a second. But it's cheap, pretty cheap. It's pay for what you use, just like everything else. You pay per gigabyte of storage. You also pay for data transfer for requests and retrievals, the data transfer and the management and replication. So what you're paying for when you pay for this service is the actual amount of data that's stored. You also end up paying for when you're accessing your files, for the amount of times that you access your files and get things. You might pay for the data that's transferred when you are transferring files, over their network. And you're paying for the management of replication as well. So it's a couple of different things that go in there, and it sounds like a bunch of different things you're paying for, but like I said, it is pretty cheap. And we'll go over some of the cost of it, and I'll send you this pricing right here so you can see yourself how cheap it really is. And they have some calculators on here. It does take a bit of time to get comfortable using Amazon's calculator, but cool. So for the very first, so this is for S3 standard. We're going to learn about the different storage tiers, S3 classes, but the first 50 terabytes, that's a lot of space. That is a whole lot of, it's a pretty good amount of space. The first terabytes are charged, ow, just bit my tongue, are charged at 2.3 cents per gig. It's 0.23 cents per gigabyte. Okay. So pretty darn cheap. All right. Up to 50 terabytes. Oh, yeah, to change the inbound IP. That makes perfect sense. I'm glad you got it as well. Yeah, so pretty cheap here for 50 terabytes a month, and then your price goes down a little bit for the next 450 terabytes. Look, that's a lot of space, man. You're not pushing. There's no reason why you on your own is pushing that much data. A lot of businesses and stuff. This is this is certainly reasonable, and this is the most expensive. This is the most expensive of the storage options. It actually gets cheaper as you go down in the other sections. We're gonna talk about those in a second, but you can also see that, like, if you look for like how much it costs to retrieve things, and you're like, oh man, all those requests and stuff is gonna cost me so much. It costs less than a cent for 1,000. It charges you per 1,000 requests. Okay. For get when you see what's there and stuff, and select, look how little it is. It's 0.0004 cents per 1,000 requests. Okay, so Think about that. It's per big bulk item of requests, and so it ends up being pretty cheap, even though you are paying for a lot. It's pretty cheap. So all the stuff that you transfer in to AWS is free, but what costs is the data out. So first gig is $0, and the next amount is 9 cents per gig, and so that's actually kind of expensive, to be honest. But yeah, use Glacier as your personal backup. Yeah, exactly. So I'm about to start talking about that. I'm about to stick a bunch of stuff, archive a bunch of stuff in there for sure. So that's that. That's just some of the information on pricing if you want to go through that pricing, but it's pretty easy on your wallet. Okay. Yeah, pretty cheap. And you pay, these are the things that you pay for when you use it. Scalable. Okay. Scalable. This is one of the biggest things. It is infinitely scalable, and they are, infinite. Yes. Okay. Sure. It's not infinite. Sure. There's a limit to everything, but as far as you're concerned, as far as everyone's concerned, this is an infinitely scalable service. All right. There's no space limits. There's no total space limits. We'll get into what the limits, where there are limits, but there's no total space limits, and it is network wise as well. It is scalable. So people, if everyone in the world was accessing the data at the same time, now realistically, if everyone in the world was doing it, it would cause problems. But it scales up to however many people it needs to serve to, and you don't have to worry about that. You don't pay more for that. That's why you're paying for the requests. Amazon handles all of that for you. You don't have to worry about any of that. And you can get it any amount of data, anytime, anywhere. It said it's web-based. It really does mean this. For the most part, there's a little star by any amount, but anytime, anywhere is why this is so darn cool and why people love it so much. Okay. Yes, one limit is one object cannot exceed 5 terabytes. Correct. And also you can't push more than 5 gigabytes in a single post, but we'll talk about that. So S3 is a database? No, S3 is not. S3 is a simple object storage service. It is there to store objects. Again, think Dropbox. Right now, you should be thinking exactly like Dropbox. The same way you take files and you stick them on Dropbox, or think about Google Drive or something like that. You take objects, you stick them in there. We'll talk about what objects are, but it is a storage service. It is simply there for you to store data inside of it. Okay. But it is extremely durable. This is things that people love about it, and this is what people will talk about all the time. The famous 11 nines of durability, okay, and 4 nines of availability. So durability is going to be how your data is it going to survive? Like what's the percentage of your data is going to be intact and available whenever you need to get it? The 4 nines of availability is, hey, like it's not talking about whether or not your data will be lost or anything like that. It's talking about whether or not you'll have access to it over the network. So that has 4 nines of availability, but only 3 nines are guaranteed. And so what does that mean? What does 11 nines mean? What does 4 nines mean? It means 99.999999999%. I guess how many I said after that, but it means 11 nines, 99.9 more nines, okay? And 4 nines of availability means 99.99% of availability. And so this is of the total time that this thing is running. It's running all the time. And so 99.999999999%, you can be sure that you're not going to lose any data. And you can bet that 99.99% of the time, or 9% of the time, that it's going to be available for you to get. Okay. So that's pretty important. They will ask you how many nines of durability does S3 have, or they might say what service guarantees 11 nines of durability or something like that. They used to tout this all the time, but that's pretty important, especially when you're talking about data. It's pretty important that your data is that durable. All right, the probability of the object will remain intact and accessible after a period of 1 year. 100% durability would mean that there's no possible way for the object to be lost. So this is just a little explanation of that up top. 90% durability would mean that there's a 1 in 10 chance and so forth. So yeah, so there's almost a 0% chance, almost, that your data will be lost and not, not there. Accessing it is a different thing, but the goal here is really not to lose your data. You don't want your data to be lost. So, you can't access it for 0.001% of the time. Great, that's okay, but you want to make sure the data is intact, and you can be pretty darn sure that your data is going to be intact with S3. How do they handle this? They handle this because they do a bunch of replication. It can actually handle it actually replicates to at least 3 places, and it can actually handle 2 going down, losing 2. It's pretty interesting the way that they do it. It's pretty wild, actually, and I really want to dive deeper into how this is set up and what it costs. I mean, I don't know, pretty crazy. But this storage, and this is what you need to know, because they will ask you questions like this on the test. They'll say, hey, what kind of, a company has to save some things, has to save some data, and they want to make sure it's saved in, as an object. What thing should I use? It's very important to know that S3 is object storage. Okay, this is a concept that I find out not a lot of people end up truly understanding. But yeah, it's object storage and not block storage. So your hard drive on your computer, even your RAM, this is, even though it's flash storage, it's block storage. What it does is it saves blocks of data all around the disk, and when it's retrieved, it goes and grabs all those blocks and sticks it back together. That's great. Works well. Block storage is pretty important. Object storage, on the other hand, is a kind of higher level form of storage where your data is saved as a full entity. It's an object, and that object is the data itself that gets saved, as well as metadata and other information about this data, about what's being saved here. And so it's a little bit different. Let's also be clear that there is absolutely some type of, like, block storage is the main form of storage. S3 is for sure backed by some type of block storage device. Okay, these things are getting saved to a normal hard drive, guaranteed, somehow, some way, somehow they're getting saved to block storage. But the S3 service itself, this is object storage. It saves these pieces of data along with metadata about that data, that describes the data, that gives it IDs, that has a bunch of information about it. They save it together as one whole object. It also means that the way that it's stored in the service is way different than you're used to on a normal file system. It doesn't save this in the same way, and I can kind of show you when we hop in there. You'll start to see what that means a little bit. Okay, so all you need to know is that S3 is object storage, not block storage. Okay, so buckets. Buckets are what we are going to save things to. So instead of saving them to a drive, we're going to save things in a bucket. So storage volumes in S3, volumes of storage, are called buckets. It is a universal namespace, so names must be unique globally. All right, so you're going to pick, when you get a bucket, you're going to need to make sure that bucket name, it has to be unique worldwide. All right, it's got to be unique across the entire world for you to be able to use that bucket. So that's pretty important. So, once somebody takes the bucket name that you want, it's gone. It's gone until they delete it. All right, so must be unique. And objects can be from 0 bytes to the small. They will ask this on the exam as well if you want to take any of the exams. The smallest piece of data that you can have in S3 is you can have a 0 byte file in there. You can have an object that is 0 bytes, but the largest singular file you can have, the largest singular object, let me stop saying file, the largest singular object you can have is 5 terabytes. That's the biggest file you can have. Another thing here that you need to know is that this is an API. We talked about that. There are some methods that you're going to use to move data around, and it showed you that when you said like when you post or when you do get requests or something and select and stuff like that, it charges you different amounts. There's also a maximum on when you put data into an S3 bucket, you're actually running a put request, or maybe it's a post request, but you're running a put request. And the maximum size of a single put request, if you're trying to put, let's say you're trying to put a 5 terabyte file up there, you actually can't do it. You can't do it, like you can't just make a put request and put it up there. The largest size for a single put request is 5 gigabytes. All right, so it's kind of easy to remember because they're both 5. So 5 gigabytes is the largest singular request you can make for a put, and 5 terabytes is the maximum size for a single object inside of this bucket. You can, so you might say, how do you upload something that's bigger than 5 gigabytes? Well, they have something called multi-part upload, which basically breaks up the file into different chunks and uploads them all and joins them back together later. But this part is a little bit more important. You can have things that are 0 bytes, and the largest item you can have is 5 terabytes, but there's no limit on the entirety of the bucket. You can put unlimited things in the bucket, but the biggest singular object can be 5 terabytes. So that's pretty important to know. What's up, 55 Keys? Good to have you. Welcome to the channel. What's up, G Labiros? I missed the follow. Sorry about that. Welcome, Sweetie Pie. Welcome as well. Hopefully you're still here. Lior, I missed a few people. My bad. All right, so now let's talk about data consistency. Data consistency. This is going to be kind of how your data is put together when it gets up there and how you are going to gain access for it. I wonder if people use S3 for personal backup and storage. Yeah, 100%. White Wolf, I use it for some things. So after I record all of these streams, they end up being, depending on how long it is, between 8 gigs and 14 gigs. And that takes up a lot of disk space. So what I end up doing is I end up every so often, like twice a year. Honestly, I have a lot of storage space. I have an 8 terabyte like Lacy drive over here. I will run a massive transcode job. I will transcode them to a different format that's smaller. It takes forever. It takes days and days for it to work. And then I put them into Glacier. And we're gonna talk about the different storage classes, but there's some cheaper ways to store things when you just want some backup and stuff. That yes, I'm sure tons of people are using it for that. And yeah, you can use AWS CLI. We're gonna hop into the AWS CLI in a few minutes actually, and do a lot of this stuff. So data consistency. Initial uploads of new data objects are immediately available. And this is an important S3 topic. Initial uploads of brand new objects are immediately available to you. So this means that if you make a request to put data into the bucket, say, hey, I'm ready to put data in the bucket, and you put data into the bucket, as soon as it's done, if you, the split second after, if you make a request to get that data back and to read that data, it'll be there and you will have access to it, okay? This is called immediate consistency, all right? Everything else, every subsequent update is what is called read, sorry, that's called read after, it's called immediate consistency, or it's called read after write consistency. Sorry, I'm tripping. Read after write consistency. So that means you can read it immediately after you have written it, okay? It is immediately available for you to get right after you write it. All right, this is only on the initial upload of an object. The first upload, and not the first upload in the bucket, the first upload of a new object, okay? As long as it's a new object in the bucket, the first, you'll be able to read it immediately after you write it, okay? All updates, okay, to objects and deletions to objects will become available eventually, okay? This is called eventual consistency, and this is a big thing. It's a big thing. One, they do ask questions about this on all the exams, maybe not all of them, but the associate level exams for sure. And it'll definitely come up. But it has a lot of implications on how you do things. So what does this mean? This means if I put in a file, if I put in my resume, let's say I put my resume into an S3 bucket, for maybe I wanted to deliver it to someone and maybe I'm having trouble. Maybe I'm sending them something that's too large to send over email. I put it in my S3 bucket and I give them the link immediately. They try to grab it. They can get it. Maybe there's an error with it. Maybe there's something wrong with it. If I say, oh no, shoot, made a mistake, let me go ahead and fix this thing, and I make changes to that object, changes that file locally, and I upload again that object with the changes, with the same name, and I upload it as the same object. It's possible that if they request it immediately, and it's also likely that if they request it immediately, that they will get the updated data, but it is not guaranteed, and it eventually will catch up. And the reason why this happens is because it has to take time to propagate around. When you upload something, it is not only saved at the point in which it was, the point at which it was written. Every time you upload data, it actually gets immediately copied to a bunch of different locations. And when you request data back, you might not be getting it back from the origin location that you uploaded it to. So if something's already there and it's been propagated around to all those other locations, if you make an update to it, it might take a little bit for those updates to get around and overwrite in all the other places. But this is called eventual consistency. The data will be eventually consistent. You will eventually get the updates. It also is a big deal for deletion. So if you delete something, it might take, if someone tries to go request it and you wanted it to be gone, they may still be able to get that data for a little bit, okay? So be careful with this. This generally is only problematic when you are doing lots of batch jobs and stuff. You really need to be careful if you are doing some type of batch job where things are grabbing, updating things in the bucket, and then other things are grabbing data from this bucket. I've run into so many race conditions and stuff where we had a job that updated thousands of JSON files in this bucket every few minutes. And we could not figure out, there was another job that was retrieving data from this thing, and we could not figure out for the life of us why we weren't getting the stuff that we were supposed to be getting. We were making changes, couldn't figure out why this was happening, and that had to do again with the eventual consistency of, yeah, most of them would be right, but a lot of them weren't, and it was tough to figure out. And then we would go check the bucket, like, oh, the data's here, like, why? Like, it looks right now, because when we checking it, it's now consistent, it's there and it's available. But when the application was getting it, it wasn't. So it can be pretty problematic. Is that a sign language GIF? I don't know. I don't know sign language. Maybe. Let's see. Data consistency is a table topic for AWS practitioner cert. I don't think so. The certified practitioner is more about knowing what services do what. Like it'll ask you, hey, what AWS service would be best for people who wanted to, store this amount of data for long periods of time at the cheapest price or something like that. That is more so what the practitioner cert is, I think. It's more just, it's covering kind of their just an understanding of the services that they have and knowing what their services do, rather than how they work under the hood. All right, so it's important to know the very first time you write a new object, it will be immediately available to you if you try to read it. So that's read after write consistency, and anything else, any subsequent updates or deletions will be eventual consistency. It will eventually become consistent. And thank you so much. I appreciate, every time I wear the dashiki shirt, I get a lot of compliments. It is not, people always ask me, because I got the hair. So I was like, oh, is that like, is that your culture? And I'm like, man, look, I don't know. I bought this on a cruise like a tourist. This is my tourist shirt. I think I got this in Barbados. But like I said, I told y'all, your boy, I'm Jamaican. Okay. I know all the words to Cool Runnings, and that makes me the most Jamaican that you can be. And maybe it is. I have no idea. I have no idea. I am. My mom's side of the family is like Jamaican, and I'm kind of far removed from it. Okay, I shouldn't say this. I'm not gonna say it. No, I have to say it now. I started saying it. It's really funny. So my wife always she's always playing with me, because I don't know, I know the Jamaican side of my family well, but I don't really know my Jamaican roots all that well. And so when it's convenient, I'll bring it up. You know, we went to Island Cuisine, which is a nice Jamaican restaurant around us, and you know, I'm like, oh, this is my food. You know, I know all this stuff about this, and I was telling her, hey, like, you know, I hope you know that that the baby that you are baking, you know, in your body right now, that's a Jamaican baby. That baby has Jamaican heritage, and we got to make sure the baby knows about these things. And my parents were coming over to kind of visit and have lunch with us, and we were going to get food from the Jamaican place, from Island Cuisine, and and I forgot what I asked my mom, but I think it was about coconuts, and my mom was yeah, like very casually in the text was like, yeah, like, you know, I mean, I used to climb coconut trees, and I was like, see, that's the heritage. And I was trying to tell my wife, like, look, the baby is gonna have it in their blood. They know how to climb coconut trees. That's what we do. That bobsleds, this is what I know. It's bad, that's all I know. I've been a couple times. I think we're gonna go back later next year. But hey, you know, one day my family will have to school me on all the things that I don't know. But hey, my baby is of Jamaican heritage. I'm of Jamaican heritage. You know, we'll learn. We'll learn. So if anybody wants to teach me any of this stuff, I know some things. I'm not completely oblivious. Like, I'm not completely oblivious. The problem is I know stuff. But all of my friends who also have Jamaican heritage, you know, they always make you feel like you're not Jamaican enough. And I'm like, dang, man, well, I knew this stuff. I'm sorry I didn't know the rest. I gotta learn, you know, it's just, I'll get there. Okay. Now that I'm having a kid, I'll make sure that they get there with me. We'll get there together. My mom was not, I don't think she was born there. I think she lived there for a long time though. Like my aunt, like her aunts and like my grandmother and stuff, they're 100% full. Like I can't understand them half, like a lot of the times. She wasn't raised there. I think she came here when I think they came back here full time when she was like pretty young, maybe like 8 or something, I think. And they've been here since, but yeah. Oh no, I cannot speak any patois at all. I can understand it just a little bit, but only if someone who has been in America for a while is speaking it. It is too fast for me. And again, my mom also doesn't, she doesn't, that's not something she didn't do around us, or like, so like, I don't know it. I grew up there and people tell me I'm not Jamaican enough. Yeah, I mean, your name's Jamaican Thunder, so that's pretty interesting. But yeah, you know, Wagwan, you know, I got a little bit, but you know, it definitely, as I'm getting older though, and especially as now I'm having a child, definitely will be doing some more digging. Like this is not a situation where I don't have access to any of my Jamaican family. Like I talk to them a lot and like I see them a lot, and they live here. Like a lot of them now live here. The ones with the strongest accents and stuff, they live close to me. I have access to them, so you know, I'll dive into it for sure. Now that I'm, you know, having a little one, we gotta, you know, find out who we are. But cool. All right, let's keep going. Sorry about the sidetrack. It's fun to get sidetracked sometimes. But thank you it all started with a compliment on the shirt. Thank you. But I just want to be very clear. This was purely a tourist decision, and I should have got more than one because I get a lot of compliments. All good. Okay, S3. You know, sometimes you need a little break from the stuff that you're doing though. It'll help you be able to save more in your brain. So storage classes. This part is important. This is the part where you start to learn how to save companies money and do things in a way that can be efficient and beneficial for the organizations. This is what they pay you for. So you have a couple of different classes of storage here. So we have standard storage. This is what you get by default. You upload something to S3. Standard storage is what you're going to get. This means I can immediately get access to data. All those 11 nines, all that stuff is what you get. This is what we've been talking about the whole time. I'm gonna put the standard intelligent tiering at the end. To be honest, there's actually some more storage tiers now. We'll go look at them, but there is a storage tier down. And I don't want to say down. There's a different storage tier called infrequent access. So standard, infrequent access, storage tier. And so what this means is, hey, you can store data here that you don't think you're going to access very often. All right. We will charge you less money to hold the data. We will hold it for less money, but we will charge you more to access it. So the fees will come in if you do try to access this data, because we're going to put it on some systems. We're going to store it in a way that works a little bit better for us financially if you don't access it very often. All right. And so if you have, maybe you're working with a law firm or something and they have a bunch of documents that they keep around, but people do look them up fairly frequently. Like, I mean, maybe someone's touching it, once every 2 months, 3 months or something like that. And it's just only once. Infrequent access might be a good way to save yourself some money on the mass storage of data, but pay a little bit more when you do need to access your stuff. And so the pricing, you got to go look at the pricing, but it kind of works out. You need to kind of determine what works best there. So that's infrequent access, if I'm infrequently accessing my stuff. Then we have Glacier. Glacier is a long-term archival service. So it is part of S3, but Glacier is where you want to put things where you are very likely not going to need this stuff, or you're not going to need it for a very, very long time. And so you want to put this stuff there. It is very cheap to store things in Glacier. It's very cheap to store things in Glacier. But again, the cost for retrieval is even higher. So much cheaper for the storage. And so we can look at the pricing, much cheaper for the storage, costs a lot more to access it. And not only does it cost more to access it, the time it takes for you to be able to retrieve it is significant. So it may take hours for you to retrieve something. If you go into your Glacier and say, oh yeah, there's this old PDF I wanted to share with everybody. And I might click on it and say, cool, retrieve this thing. It might take 3 to 5 hours for this thing to now become available to. But again, I pay more for that retrieval. If I'm only retrieving a couple things, this is no big deal. When we say pay more, we're not talking about paying $3 or $4 for a retrieval. We're talking about now paying, instead of paying, 0.002 cents, we are now paying to retrieve this thing. I'm now paying, 2 or 3 cents to retrieve it. So it's, if you're not retrieving it often, this may work really fine, really well for you, but it is, again, for archival. Just, a lot of times you'll use this for compliance reasons. Maybe you're working for a company and they're legally not allowed to delete, to remove. They got a bunch of old files, old documents and stuff where they're legally not allowed to delete them. Or maybe they have to hold them for 7 years, like legally. And so it's like, hey, no one's ever gonna use these things, but we legally, if we get audited or someone tries to sue us, we need to have access to these things for 7 years to prove that we are compliant. So you stick them over in Glacier to save yourself. Yep, screams HIPAA, screams in HIPAA. Yep, save these things here, and just kind of leave them there, let them ride, and we can delete them whenever we need to delete them. And again, it's very, very cheap to store in Glacier. And then Glacier Deep Archive is just another deeper level. Even on top of that, is even cheaper, and the retrieval is even longer and even more expensive, but it's even cheaper if you need to keep stuff for a very long time. And you're basically positive you're never going to touch this stuff unless it's an extreme emergency. But yeah, 100%, it's even cheaper if we go look at that page and we can see some of the storage class pricing. And let's talk about some of this. The durability and things change a little bit as you kind of get down through these different things. But this is what you have. The top one that we have up here was that intelligent tiering. All right. So what intelligent tiering does, I was going to hold off on this for a second until I told you about something called lifecycle policies, but it's okay. We can learn about it now. Intelligent tiering will allow S3 to kind of figure out where something should go. It will either promote or demote to a different storage class, both depending on things that you can set up, but also it'll be intelligent about it. It'll say, hey, this file hasn't been touched in 6 months. I'm gonna, or first, it hasn't been touched in 3 months. So I'm gonna put it into infrequent access from standard to save you some money automatically. And then after 6 months or 8 months, it says, cool, I'm gonna send this thing to Glacier because you don't touch this thing here at all, and it will manage these things for you. Really, really nice. You might say, oh, like, what's Amazon's incentive to save me money? Well, the incentive is capacity for them. Like, I know that they're jumping through so many hoops to be as efficient as possible, and the way that they have these things done, they, you know, if they can put your stuff on the cheapest thing for them and still charge you money, I'm sure they will want to do that because they can have capacity for other people to use the more expensive products, as well as you. So it's really pretty interesting. To it creates a multi-tier billing system. It charges you different rates for those different services. Obviously, it aggregates it all, but it is pretty darn cool. But this is also something that you can do yourself. But it works pretty well. It definitely works pretty well. Yeah, designed to keep so you never leave AWS. Also true. Also very true. We're gonna talk about something in a second that really is designed to make sure you don't leave AWS. But this is another important concept. So those different tiers, make sure you make sure you kind of understand that there are different tiers depending on your use case of your data. Standard, if you need to access things pretty often, you're putting things and you need to access it pretty often. Standard, if you don't need to access it, every couple of months at a time, infrequent access might be your best bet for that. Glacier is for archival, when you just likely won't access the stuff, but want to keep it, you want to keep it around so that you can get it within a reasonable amount of time if you do need to get it, but you're likely not going to get it. And deep archive is like, hey, there's like no chance I'm going to need this stuff anytime soon or needs to stick around for a long time. And again, you save money on the permanent storage of it, but you pay a little more to retrieve the data should you need it. All right, object versioning. This is a big deal as well. They will ask questions about versioning here, knowing that in an S3 bucket, you can version your object. So you can retain multiple versions of an object in one bucket, just like in your Google Doc, even in just like this Google Doc right here. I can see when it was edited, and I don't have any other versions. Because I made a copy of another one. That makes sense. There's only one version of this, but if I had made a bunch of edits over time, it would show different versions that I could go back to. This works the exact same, and it'll show you multiple versions of a file as it's been changed. So if you overwrote something that you didn't mean to overwrite, you could return back. Here's the caveat though. You must pay for the storage of each of those versions. So versioning can actually get pretty expensive. All right, if you don't, yes, absolutely. It's similar to, it's kind of similar to Git, and you can go back in time and fix your problems and find older versions that make sense, or whatever. Maybe you need to reference something older to see what changed. But yes, but you must pay for each version. Like, that is more storage you must pay for, but it is nice. Once you enable it, you cannot disable it. This is a big one. Once it's enabled, it cannot be disabled. And this is new. Suspension is relatively new. You used to could not be able to suspend it. You used to not be able to suspend it. It's not relatively new. It's just there was a time when you could not suspend it. Once you enabled it, the only way you could disable it was to delete the bucket. That's it, and recreate it. Only way. Correct. Object versioning is per bucket. That is, in fact, correct. Second billing cycle. So you're something that you would have to enable. Each individual bucket is like its own different little storage partition. And yeah, it's per bucket. It's not across your whole account. So that last part is really important for you to remember. Once you enable it, you cannot disable it, but you can suspend it. But you're still going to be paying for all of those versions of the files you already have versioned. So be careful with that one right there. You don't pay anything for the versioning itself. Like, having it enabled, if you enable it and don't create multiple versions of your files and stuff, it's fine. You won't pay anything extra for that, but it just allows you to do it. What's the difference between disable and suspend? So what suspension will do, so that's actually a good question. So what suspension will do, it will stop, I believe it'll stop new objects from being from you being able to create them. It'll basically create overwrites for objects. I think it will also stop even existing things from it creating new versions. You just overwrite the newest version. So essentially you'll lose your newest version every time when you overwrite it, which is essentially what stopping it is. Absolutely. But the problem is it will not remove any of the existing versions that exist inside of the setup. So it would be up to you to delete all of the existing versions. And I guess, yeah, I guess essentially that achieves the same outcome if you leave it like that. But yeah, like I said, there is a time when that didn't exist. So it's actually really good to, like, the last time I read that, I was like, oh wow, I didn't know. I've always been on the assumption once it's on, it's ain't nothing you can do about it. And yeah, you can suspend it, but you cannot disable it. It's still something that is available on the bucket. That's object versioning. And so life cycle policy. So this is where the intelligent tiering came in for the S3 storage classes. To manage your objects so that they are stored cost effectively throughout their life cycle, you could set up these policies that said, hey, once something has existed in standard tier for 5 days, go ahead and send it down to infrequent access. And once it's been in infrequent access for a week and it hasn't been accessed, go ahead and send it down to Glacier. And so you could do that. The intelligent tiering, you can do that manually, and you can still do that manually. You can set up policies for the management of different files in your bucket. Okay, so it's pretty cool. You can determine what happens when it happens if you want. You can save a lot of money doing this. You really, I've seen specifically the just storage portion of bills, going from just storing everything in standard tier to implementing bad lifecycle policies, like really weak lifecycle policies. I've seen just an S3 storage bill go from like $3,800 a month down to like $2,200 a month by putting in bad sourcing. And again, for larger companies, that's probably not a crazy amount. It's probably not a crazy amount, but it could definitely have been dropped more than that. But think about those efficiencies as you make those efficiencies across the entire stack. You can really save companies like massive amounts of money by doing these things properly. All right, so lifecycle policies, just simply, AWS is like drugs. It kind of is. It's pretty nuts, actually. All right, so we'll talk about this in a second. We're gonna set up a static website in a second, but first I want to talk about Snowball. I really want you to know about Snowball. I also want you to know about AWS like accelerated transfer real quick. But Snowball, AWS Snowball is pretty dope. If you are migrating to AWS and would like to use S3, it could be problematic if you have tons of data to move. Okay, what companies have lots of data. They've been collecting data on you for years. Companies have massive amounts of data, and it can be pretty tough to migrate to a service like AWS. All right, my upload speeds at my home, even if I wanted to migrate all of my my uploads to AWS would be so trash. If I was even trying to just get my recorded videos, it would take so long for me to upload it up to S3 if I needed to do that. It's pretty nuts actually how long it would take to do some of this stuff. So people need a faster way to do this. Companies, organizations need a faster way to do this. Snowball is a secure physical device. It is a physical device used to take massive data make massive data transfers much easier. Okay, so they basically ship you out a giant hard drive, and when I say giant, I mean giant hard drive that you plug into your own systems, move the data onto. They ship it to you, you put the data on it, you seal it up, ship it back to Amazon. They upload it to their systems. It is a faster way of doing this, and again, it's for petabyte level storage. It's for so petabytes. So 1,000 megabytes is a gigabyte. 1,000 gigabytes is a terabyte. And so maybe most computers have between 250 gigabytes up to maybe 2 terabytes. Like it might go there. A petabyte is 1,000 terabytes. 1,000 terabytes is pretty ridiculous. And this is for petabyte level storage. And this is what they look like. The one on the left, it's surprisingly small in the image. It's much bigger than it looks over on the left. That is a Snowball, and it is much bigger than it looks. It's like a desktop computer, a little bit bigger than a desktop computer. It's pretty robust. It's pretty durable because they ship these things around to crazy places to get data onto. It has a little computer set up in it and stuff, but you just basically plug in your stuff network wise, and you just get it all in there and ship it back. It doesn't look the best, but it does the job. Pretty important thing to do. And like I said, petabyte level of storage. I think these come with max maybe 5 or 6 petabytes available. So a lot of stuff. I don't remember what it is, but it's pretty crazy. The one in the middle, is wild. This one is relatively new in comparison to the first Snowball. It's been out for years still, but it's actually so in demand that they often don't have many to give out because they're super in demand. The one in the middle is called a Snowball Edge. And the reason why this is so popular is because it is they only go up to 80 the edges only go up to 80 terabytes. Interesting. That makes sense though, because of the other stuff they have in there. But they're designed to do the same thing. But what they give you is they give you not only storage capacity, they give you compute capacity. So they give you an equivalent of like some I don't know what tier server. It's like an M2 large or something like that. They give you the equivalent compute capacity of a pretty big server, and it can run outside of the data. It runs outside of the data center. So when would you use this? When would anyone use this? Any people use this to do processing and data collection at remote locations. So scientists, all kinds of people take this to remote locations to be able to process data, to save data, to do all the stuff that they need to do for whatever their given task is. It's pretty interesting. When it first came out, I was like, man, like what use case would this be for? And I started to look it up, and man, it has so many real world applications. It's pretty nuts, and has been by far one of the most intriguing products to me that Amazon has to offer. I have no need for it. I have literally no need for it. But it's on planes. They put them on planes. Yeah, 100%. The FedEx Logistics Network estimated to have higher bandwidth than the entire internet until 2040. Whoa, that's pretty crazy. But they run these on planes and stuff. It's pretty crazy what these things are used for. But yeah, pretty crazy. FedEx bandwidth. That's pretty nuts, actually. I gotta read that. Bandwidth always, oh man, like types are crazy. But yeah, snowballs are pretty cool. Now the one on the right, you might be asking yourself, what the heck is the one on the right? That's the big pop-up. Okay, and this is not a meme. It's not a meme at all. I think at reInvent 2017, maybe 2016 or 2017, they drove this thing up on stage, and Amazon will literally send you an 18-wheeler. They'll literally send your company an 18-wheeler with fiber optic internet. It is the snowmobile. It is the snowmobile, and they'll send it to your organization, to your data center, and you can plug it up. I think it's like hundreds of petabytes of data. Maybe it's only 100 petabytes. I don't know, but it's over 100. It's 100 plus petabytes of data that you can do. Fiber optic cabling. You plug it in, and you get all of your data there. The driver drives it back to Amazon, and they hook it back up to their data centers, and they get it all in the cloud. And it's pretty absurd, actually. Like it's pretty nuts, like to think about. But like, you would be surprised at how often these are utilized. And I think it's super interesting that they did this because I understand why they even felt the need to go do this, because again, you're talking about vendor lock-in and getting people to stay with you as long as possible. If I send you a truck, if you have enough data that it literally takes a truckload of data it takes a truck to move this data into somewhere, you aren't going to take the hassle of getting away from us. You're like, even if we're losing a ton of money on the transfer of this data, which they're probably not, because they're probably charging you for every dime that's spent to do this. You're likely not gonna be thinking about moving from us anytime soon. It's pretty crazy, but yes, armed escort available in request. It is nuts, and it is 100% the biggest USB you've ever seen, and it's for large organizations for sure. I don't know. Like in my mind, for some reason, I want to say, hey, I would love to create an organization that one day we would need to call a literal semi truck to move our data somewhere else. But like, I just don't know. I don't know. I don't know. It just seems so absurd. But as companies are gathering more and more data, the more data we have, like this is going to become more of a thing. It's going to have to happen. How can you possibly protect all the data? Hey, I don't know. It's so crazy. They literally use Amazon trucks to move petabytes of data. I sell it every, yeah, seriously. It's nuts. Hopefully that also shows you the scale of what Amazon is doing and what these cloud service providers are doing. It's pretty nuts. And to know that these things are utilized heavily. Like these things are not niche items, like they're used very, very heavily. Snow cone. Is that new? I don't know about that. Hold on. AWS snow cone. Oh, hold on. Yeah. Oh, they got some smaller one. Oh, and it's the edge computing device. Okay. So I didn't know about this. When did they announce this? Was this, what year did they announce this? Well, I'll tell you right now. I'm going to do a project with this. I don't know what I'm going to do with this yet. I will be doing a project with this. No, this is smaller. This is much smaller than the one on the left. The one on the left is actually a pretty large device. Like it looks small here. It's actually a pretty large device right here. This looks much more reasonable. Let me get back to it. And like I'm gonna do something with this. Only does 8 terabytes. I don't know what I'm gonna do. I'm doing something with this. How much does this cost? You know what I should do? All right. So what I'm gonna do with this, I'm planning on, I don't know, I have no idea what the cost of it. Oh, pricing, let's see. Pricing, service fee per job, per day fee. So first 5 days of on-site usage, including the service fee. So it starts at 60 per day. Service fee is $6 a day after that. All right, here's what we're gonna do. Can run on solar or a battery. Oh, even better. So here's what's gonna happen. Well, this seems like I don't need this because I can use a phone. I don't know. I'm gonna figure something out, and I'm gonna figure out something to do. I'm planning on starting to train again because I was supposed to do a Century bike ride, and I never got to do it. And so I do want to do a Century bike ride late spring, early summer. I wonder if there's something I can do to take this with me on that ride. And I don't know. I don't know. I'm genuinely gonna think of a project to do with this. This is pretty dope. Mini cloud for the students. I mean, yeah, this is pretty dope. Heard about Snow Clone via reInvent. Was it this year's reInvent? Because this is cool. Or maybe it was last year's reInvent. I feel like if people already have it, it must have been at least last year. Lost device fee is $2,000. Could be worse, honestly. That's like, I mean, I for sure, I don't have extra $2,000 just to be given away, but I'm just saying, like, it's not crazy. Ooh, so the total cost per year would be $16,000 at list price. Very interesting. You can connect a camera, store the data, and use the AI machine learning on process to define objects in the video. That's phenomenal. Well, so I could easily change it to my bike. I have a rear rack if I want to put it on there that would fit it, I think, perfectly. Very interesting. This is very interesting. We might have to do some cool stuff. Do you need courses on Azure or just AWS? So right now it's just AWS because AWS is what I've worked with professionally. I'm certified in AWS. It's what I know. This year, one of my goals is to start to dive into Azure. So I'll definitely be offering Azure courses in the future. Hopefully I can do my first one later on this year, maybe around summertime. But yeah, I'll definitely be doing that. But I think I am going to try it out for a few days, and I can, it can be, and I can write it off. I'm with it. This is great. Or someone from AWS can accidentally see this video, or I can send you this clip, AWS, and you can say, hey, I like what they're doing over here. They're learning about AWS and they want to do some cool stuff with snowballs. And we would love to share a snowball with them for a day or a week or a month, free of charge, and also possibly pay him to use it. Thanks. I appreciate it. Reach out to you. I will reach out to you. Absolutely. I will 100% reach out to you. Excellent. That would be great. But yeah, I've been studying for Azure in one of my classes at school. There's a ton of overlap. Yeah, I'm sure so I've used Azure for sure. I've done things in Azure or Azure. I don't know. I say Azure because somebody at my job kept saying Azure, but I used to say Azure all the time. I don't know what's right, but 100%. There's a ton of overlap in cloud computing, period. But I would like to know Azure as well as I know AWS for sure. Okay. let's get back really quick to talk about the last little piece. I think that was so this was all the AWS bucket stuff. So I'm gonna do this stuff. I'm not gonna do the static website, but I'm going to give you the static website stuff. Amazon has a great walkthrough for it. I will give you that before we even get off. I'll put it in the classroom. I'll put the link to the walkthrough, as well as some site files you can use so that you could try yourself to get a static site set up. I'll also show you mine. But I think it's gonna be more interesting really quick to show you how to interact with this from the command line a little bit and to use it from the command line. There's a bunch of stuff here, but we don't need to go through each of these. You can have these as a guide, but it's just gonna show you how you can copy files to and from buckets easily, how you can set some stuff up. Let's set up our first bucket. We'll do it from the console. I'll also show you how to do it from the command line. I'll show you how to move stuff to the bucket from the console, from the command line, all that other stuff. So yeah, I found your stream today. Loving it so far. I appreciate that, Valken. Have a great night. Get on out of here. Go relax. It is a Friday. Go spend some time with your people, or just go relax. Doesn't really matter. Maybe you don't want to spend time with anybody. It's okay. Go enjoy yourself. Have a great weekend. I'll see you later. That mouth x-ray was quite something. Yeah, on the last thing for sure. I forgot what it was for, actually. What was the mouth x-ray for? Oh, the anatomy of an AWS command. So I think we've done a little bit with AWS commands already, but I'm going to, first off, do I have AWS CLI set up? Okay, cool. AWS S3 LS. This is great. I thought I was going to have to set this up. Okay, cool. So this makes it super easy for us. Let's go ahead and hop into S3 and look around the console really quick, and then we will do our first bucket. So it is a service, just like anything else. It is the top storage one right here. What are we doing on build tomorrow? So hey, tomorrow's actually not build. Tomorrow is office hours. Actually, let me confirm that. Because if it's not, I will have something for us. I'll pick something off my list, but I think tomorrow is office hours and not build. Yeah, tomorrow's office hours because we were supposed to do build last week, but we had to redo the decoded session because of the technical issues. So tomorrow's office hours. But if people aren't coming with questions, maybe we can build something small. Maybe tomorrow during build we can set up. If you want to come through, I'll still put it in the classroom. But yeah, we can. I think there'll be time to do that tomorrow. So if you wanna, if you don't want to go through the worksheet by yourself to set that up, come with it tomorrow. We can absolutely do that at the end of office hours or at the beginning of office hours. Either one. It's not a crazy intense process. Might be something cool. Maybe we'll try to do that every office hours. Is if there aren't a ton of questions, or maybe at the very beginning we'll hop into something real quick and then we'll start answering questions. So yeah, we can do that. But I can also give you all the stuff too, so you can do it yourself. But cool. So AWS commands. So we can interact with things from the console and from the CLI. I'm gonna go in here into the S3 console. Okay, so just click services, find S3. Now I have a number of buckets because I'm managing a number of websites. Because I know Amazon the most, I go to a couple meetups and stuff, and so they're like, hey, I need you to host the BeMoreBlack.tech website. If anyone is in Baltimore and is interested in tech, it is not a Black only group, but it is a group designed to help Black people get into tech. BeMoreBlack.tech. You can check it out. We got a little website. We used to meet up every Thursday and do some cool stuff. But if you're interested in never doing anything, whenever we can get back in person, there are some events and stuff. We got some stuff there, but I have a bunch of different buckets here. A whole bunch of different buckets here. Academy.mastermind.io. All of my wedding photos are in this bucket because we were going to make a website out of this. Yes, it's okay that it's public, but even though you can't get to it yet. But yeah, all of our wedding photos are in there because we were going to do some stuff with it, but we never did it. I host a couple of websites. So that website that you just saw when I went to BeMoreBlack.tech, it's actually hosted out of this bucket. So that is what the static website we were talking about was. I'll explain that a little bit in a second. But all of these are buckets. These are partitions. These are storage places, okay? And all you got to do to create a bucket is click Create Bucket. All right? Now, remember, bucket namespaces they're universal, okay? So it needs to be unique. So I'm gonna create a test bucket right now. You cannot name yours the same thing that I named mine. It won't work. Okay, so make sure you choose something that works for you. And so I don't consume a good named bucket, I'm just gonna say today is gonna be Horizon 1 2 3 4 5 6 7 8 9 0. Okay, that's what I'm gonna call this bucket. Please don't make it before me. And then you can leave it in whatever region you want to leave it in right now. Doesn't really matter. US East 1 is closest to me. And there's going to be some access settings. Right now, it's going to be set to block all public access. I'm going to unclick that. Actually, no, I'm going to leave that. I'm going to leave that there right now. I'm gonna unclick it. I'm gonna unclick it. You can leave it or not click it. By default, it will block all public access, so only people who can log into the AWS console and have access to it, or can access this from the using the AWS CLI, have the credentials, can access the things inside of here. I'm gonna unclick that button so that we can mess around with it a little bit more. Yeah. And it's gonna give you a little thing that says, hey, like you probably shouldn't be doing this, which is weird because you can use these to host websites, which you have to do this with as well. So it's really weird that it always gives you this little error. But go ahead and if you do what I did, click this. You don't have to click it. You don't have to unblock everything. You'll still be able to push stuff to it. Bucket versioning, we'll leave it off. Tags, I'm not gonna do a tag right now, but we talked about that before. You can also have encryption in buckets. This is pretty important. So you can encrypt the data in buckets. You have a couple different options for it. You can you have KMS encryption. You have what's the other type of encryption you have? My mind is tripping right now. You can make your own KMS keys and do that. You can have S3 buckets default encryption right here if you like. You can also encrypt for different things. There's a bunch of information in here on this, but all you need to know right now is that you have options to encrypt the data that is in your buckets. This is something that might be good for you to do. And so I'll leave that disabled for now. I don't want to encrypt anything. I'll click the advanced tab just so we can see what's in here. Object lock, I actually don't know what this is. Using a write once, read many model to protect objects from being deleted or overwritten. Okay, so you can lock objects so they can't be overwritten, I guess. So I guess that's cool. Appreciate that, Mr. Moon Slam. I really do. Thank you so much. I'll start to wear. I have quite the shirt catalog that I'll I've got shirts with cacti on it, shirts with scuba divers on it. I have all kinds of fancy shirts that now I must start wearing for the stream, just so I can come in and you all can fill my love cup by saying, giving me compliments about my clothes. I appreciate that, though. I really do. Thank you. Let's see. So yeah, that's all the options that we have in here. There are significantly more things you can do with the bucket, but this is what it gives you during setup. And click create. Just go ahead and click create. And just like that, you have a storage device that will accept unlimited amounts of data. All right. And so it's, they give you all this crap up top and it says create buckets. And it says bucket created, and I can go look at that bucket. So you just find it on the list or search for it. And I already forgot what we called it. I called mine Horizons 1 2 3 4 5 6 7 8 9 0. And now this bucket is here. Phenomenal. The best. We did it. You can upload stuff, no problem, just like Dropbox. You can just simply upload it. All right. Oh, this is new. So you can just drag and drop. If I want to put some memes in here, best Bernie memes, because these, I'm not joking with y'all, man. These Bernie memes have been killing me. Like, I've been having the most genuine guttural laughs from these Bernie Sanders memes. Come on, man. This is hilarious. This is so good. People are so creative. Like, first off, I'm not lying. Memes are going to be the thing that saves the planet and brings us all together. If you can't get together behind a good meme, you're a bad person. You're like, they're so good. Like, I don't know, man. I don't know who. I gotta get really good at Photoshop, because all day I've been like, I want to put Bernie somewhere because I want to be a part of this, but I couldn't do it. Yes, memes are our generation's art. So I'm gonna save this. I'm gonna save this image right to my computer, and I'll put it right here. I'll put it in my downloads. But if I want to copy this into my storage device, just copy. It's simply a drag and drop. So it's nothing special here. You've done things like this before. You take it, you drag it, you drop it. it's going to upload right to the system. So check it out. It's right there. It's here. It's available. It lets us know how large it is. Now, remember, we said that objects, unlike block storage, it saves the data, but it also saves a bunch of metadata and information about it as well. And you can see here, it's got the size, it's got the image type and everything. And so all of that data is in here, and it's saved as an entire like thing, as an entire object. And so now it's here now, just like that. Wasn't so hard. When we did that, we're making what's called a put request, or post. I don't know which one they're using. I think it's a put here, and it uploads, and it is now here and available for us to retrieve. If we ever wanted to go get it, we could actually. So this is still the upload page. This is new. It didn't used to be like this, so it's not there yet. I click upload, I guess. Actually, let's put some other stuff in there as well. Let's take. I'll put this other one here, just so there's 2 files. Lets us know what's here, and click upload. So metadata, it's a good question. It's hard to explain because metadata is simply data that goes along with the actual data. It's usually like text data that either describes the data that you're actually passing in, but it's extra little text data that goes with the main data that you're talking about. It's really weird. A little bit of encoding data. It usually tells you information about the actual data. That's all it is. And so it could be things like just like the name and the size and stuff. It's just a little bit of extra data. Is EXIF data an example of metadata? I'm not sure actually. I don't even know what that is. Maybe. Yeah, think like the image resolution and the artist name and stuff. Yeah. Do you end up uploading the office hours and bill days? Huh. So I hadn't been uploading them, but I should. You know what I'll do? I will upload them. I probably won't. Yeah, I might as well. Yeah, I will. I'll do that because I can add them to every playlist as well. Sure, I have them. I can upload them for sure. I also have like the last 3 or 4 days that I just didn't have time to do. My automation is broken again, so I had to do it. I have to do it manually. But I should, depending on how long my internet takes to upload them, I should have them up tonight or tomorrow. I've already done the clipping of what I needed to clip, but I just got to upload them now. But yeah, I will get them. I'll get them up there. I don't know why I didn't even think about uploading those, but I can get them up there for sure. Oh, like everything. That's cool. That's completely cool. No, that makes sense. I'm glad you brought it up. Again, something I just wasn't thinking of. All right. So we got to the, where were we? Where was I at? EC2. Huh. Did I delete the, what just happened? Where is the upload? EC2. I need to close some of these. S3. Okay, it uploaded. So it succeeded in uploading, and now these files are here. So if I go to one of the reasons, so one, I can also show you one of the reasons why these things are why your namespace is global, but you can't see the file in here. There's no preview like Dropbox or anything like that. But it's here, and there's information about it. There's also URLs to retrieve it at. So check this out. There's this URI. And check it out. The URI is S3:// and I'll make it bigger. Horizon, the name of my bucket. So Horizon 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then / the name of my file. Now it won't let us see this. I doubt it'll let us see it. Oops. Oh, actually, the actual URL is different. Sorry, hold on. I don't know why I did that. I know this. The actual URL for it is different. This is the S3 URI, so I can use this when I'm retrieving this through methods that interact with AWS's API directly. But this is the actual object URL right here. So it's always the bucket.s3.amazon.com. And this is why the namespace is global, because it makes some DNS entries on this thing. So it's gotta be this. Now, I get access denied here, but this has to do with the settings on the bucket rather than the file. It is actually requesting the file, but it's all good. Oh yeah. If you're a hacker, you can have all kinds of fun with these buckets for sure, because people open them wide open. But there's also not much to get besides files. Like you can't really, you can get the files, but the files are probably already public anyway. So yeah, it's interesting. But the stuff is here, great, very exciting. I can change the permissions for. You can get very granular about this. You can set permissions for specific files or objects. Sorry, not files. You can set permissions for specific objects through this bucket policy, which is kind of complicated. Well, up front, it's kind of complicated. Remember when we were in IAM and we were setting up those IAM roles and policies, and we were doing it through JSON? This is the same way. You got to put in some JSON in here and set up a policy. I'm not gonna do anything with it now because I don't need to. But you can do a policy generator. You can also do some policy examples. So when you do the static site stuff, when you set up a static site, they'll give it to you. This is an example of it. This is an example of what a policy looks like. Very confusing when you look at it like this. Copy and paste. You will not memorize. I doubt you'll memorize how to do something like this. I copy and paste every time. You'll learn the pattern. You'll understand what's in there and what it does. And once you do that, you can create whatever policy you want once you just realize what's in there. So that's why I can't get that object by the URL. But again, it's just a holding place. It's a holding place for all your files. You know, that's really all it is for now. And I can put as much stuff as I want to put in there. Now let's interact with it from the command line a little bit. So AWS commands. Remember, AWS is the command that we're going to use to invoke the AWS CLI. And if you just type in AWS, it's just going to tell you, hey, this is, I need more information. Let's type this in. So everything in Amazon, if you want to interact with it, it is through its service name. So if I want to do something with EC2, I would type in AWS EC2, okay? And it will take more commands. But if I'm not sure what commands I have, if I type in AWS EC2 help, it will tell me what options I have, okay? So look at this. It gives me lots of things that I can do, available commands. Allocate host, tons of stuff, so much stuff. And this is why, yes, it is a burden. It's a little bit of a burden to learn, but it gets easy when you realize, hey, everything that I can do from the command line, I can do here. You don't need to go in and memorize all these things, and you don't need to do that. But eventually you'll start to pick up some muscle memory and you'll start to remember how to do certain things. And so we're using S3. So let's do S3 help. And it has way less commands. It has way less that you can do, to be honest. So really it gives you a couple of simple things like CP, MV, and RM to do. There's not nearly as much at all. Like there's a lot of words here, but like these are your commands. These are the commands right here. Okay. So much less for S3. So S3 is easier to work with. I almost exclusively work with S3 from the command line. I almost never touch the console at all. This is one of the services that I only pretty much use from the command line because I find it to be much faster, and I can just get around a lot better. So we can do the same exact thing that we just did. Well, one of the commands that you might want to do is if I want to see what was in that bucket, if I do an AWS S3 LS, it will list all the buckets that are a part of my account. So these are all of the buckets that I have in my own account. Okay. Oh, I didn't delete some of these. So these, you know what's crazy? These were at the beginning of the pandemic. We did a pretty fun serverless thing for Code and Coffee, for the organization Code and Coffee, and we were gonna set up an API for people to get a bunch of cool information and stuff, and we never dove deeper than it was. But you know, probably should delete these. But it was like, you know, you could get, you know, a little coffee generator. Like, what kind of coffee should I drink today? Because people want to try new coffee, and what coffee and coding language should I use? Yeah, all kinds of fun, just messing around with it. But you can see all your buckets by doing an AWS S3 LS. So it just lists out the buckets that you have available to you. Now, if you want to see what is in a bucket, it's the same command. So LS is the command on Linux to see, you know, the contents of what's in the current directory. If you want to see what's in a bucket, you do AWS S3 LS and then the bucket name. So the bucket name that we just did was Horizon 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And so if I do an AWS S3 LS on that, check that out. I can see 2 files here.
these are what I just uploaded. Okay, these are 2 files that I just uploaded. So great, that's phenomenal. They're there. How can I get these files? I can get these files right now to my computer by doing this: AWS S3, whoops, S3 CP. So copy, just like the Linux command copy. If you're familiar with any Linux command line tools, CP will allow you to copy, and I can copy this file down to my local computer. But this is where it gets tough. This is where I have to know that whole S3 URI. So you may have to go here to get it, to remember it, and you grab this S3 URI. But I always you'll learn what it is. And to get it, I do S3 : the name of the bucket / the name of the file that I want. So it's just kind of like getting it from a web address, and this is how I would get it right here. So I can like the copy command in Linux is copy the source file. So I want to copy this thing that comes next to this destination. It's 3 things: the CP, the source, the destination. This works the same way. CP, the source is this file, and if I want to copy it right where I am now, I just do a dot. It says, copy it right here. And if I have access, check that out. It downloads the file, and now I have this file right here on my computer. So it makes it pretty easy to move around files. It's pretty cool. I'm going to RMRF that. And then you can also sync the whole thing. So there's a copy command, but there's also a sync command. If I want to copy everything that was in there, I could sync instead. And instead of doing the whole thing, I think I could just do this. And it will copy down both files. It'll copy down both files right here because it's the only 2 files. Be careful with that because it will sync everything. Now, sync works both ways. Sync works like a Linux rsync command. You can sync a local directory up to a bucket. So if you want to copy everything from your computer, like from a directory on your computer up to a bucket, you can sync it up. If let's say you want to also have, let's say you delete some stuff, like maybe you're using it, if you're using it for backup, you can copy everything up, and let's say you delete stuff, you can add in flags to make it actually like keep it completely in sync. Like it'll delete things that are no longer there, that are in the source, and you can use that sync command to sync things back and forth, like complete directories between the 2. So sync works well as well. That's cool. We can make our own bucket by doing AWS S3 MB, which is make bucket. And I think I have to do like S3 : and think of the bucket name. I think the bucket name, let's try Horizon make bucket. Horizon make bucket. Terrible name. Nobody wants that though. And just like that, I have now interacted with Amazon. You saw before we had to click the create button. We had to go through and click all the options. Now it has a bunch of default settings, but if I do an AWS S3 LS now, check this out. Horizon make bucket is here. All right, it's there. It's great. Sync appends to the bucket or overrides it. Good question. It appends. It doesn't overwrite. It does not overwrite all the files that are already there. It works like a rsync, so it will update files that have been updated in the source. So like, let's say you push 100 files. Let's say you update 2 files on the source machine. It's kind of like Git, honestly, and you do a sync again, it will only update the 2 files that have been updated since the last run. So it appends and only overwrites if you've updated the data. And it only deletes if you explicitly tell it to delete as well. So this bucket is created. I have a bucket here, and if I want to sync all the stuff I have now, so let's say I do AWS S3 sync everything that I have here into the new bucket that I just created, which was Horizon make bucket. Yeah, deltas, 100% it's the deltas. So check that out, upload. And if I do an AWS S3 LS, the bucket that I just created, check it out. It's got those files here. Now, one thing I do want to tell you about object storage. So here, check this out. I'll show you this. So the Academy site is out of, I never remember if it's out of Academy. I think it's out of Bootcamp. I think I messed it up and it's out of Bootcamp. I do AWS S3 LS. Bootcamp, that mastermind. mastermind.io. If I take a look at this bootcamp.mastermind.io, what happened? Oh, LS, not SL. What's up? I am Hanson. Welcome to the channel. Evil Knievel, welcome as well. 99X GG, welcome. It's good to have you all. Cool. So to delete your bucket, if there's data in the bucket, do you delete it recursively? Yeah. So you can't. So by default, it won't allow you to delete stuff with stuff in it, but you can force it to delete it. Yeah, you delete it recursively. Yep. Good question. It will stop you from deleting stuff. So what did I just do? LS. What did I do here? Okay, S3 LS. So if I look at bootcamp.mastermind.io, look at all these files I have in here. I have all these files in here that serve the site, okay? Check this out. These up top, these are folders, okay? Well, as far as you know, as far as we are concerned, we're used to file systems, these are folders. Object storage does not work that way. Object storage does not have a file system in the same way. These names, the name of the file, they're simply keys for the file. It's simply a key that locates the file. It locates the metadata and everything else is kind of connected to that object. It's not actually the name or the path to a file. The reason why it has this PRE right here is because these folders are what are called prefixes. There is nothing in, so I can look at what's in icons, but there's actually nothing in icons. Icons is a key. It's a key to an object. There is an object that's called icons, and it represents exactly what it is. And the things that are in icons, the stuff that is like, if I want to see, if I do an AWS S3 LS on /icons, which is a folder, whoops, do the slash. These things right here, this is not the name of this. Well, the actual this object is not in the icons folder. It is simply an object that has the key, the name of /icons / icon 144 or whatever. Like if I want to look at this is just the full name of the object. It's not really in that folder. It's a pretty weird. It's really weird to think about. I want to throw it out there to try to present to you in a little bit. I have a video and it's someone else's video that I think explains object storage versus block storage really well. But I just want you to be aware that although they show it to us like it's a file, and even in the console, they have little icons that make it look like it's a file. There are no files. There are no folders. There's no folders for anything. Even though they'll try to show it to you as if it is a folder, where is it at? Where are these directories at? Oops. Well, they'll just put a slash there that says it's a folder type, but it's not really a folder. It is just the name of an object. So it's pretty interesting. Yeah, they added that paradigm because it makes sense for me and you to kind of understand. But if I want to remove that bucket, that we just created, it is AWS S3 RB for remove bucket, and then just the name of the bucket that you no longer want anymore, which is, hold on, I don't remember what it was called. So let me look at the list again. And if I do AWS S3 RB and paste this in, it will not work because I have to type in, whenever it says S3 URI and it gives you errors, that means you have to type in that S3:/ part. So you need the whole URI there to delete that bucket. And it says, hey, this failed. An error has occurred. The bucket is not empty. The bucket, you try to delete a bucket that's not empty. There's a couple ways to do this. You could go through and recursively delete everything before that. I think you can -F it maybe. Hold on. There's an override key. Whoops, I'm gonna type F there. There's an override key. Usually I go through and remove everything. I usually go through an S3 delete recursive beforehand, but let me see. I think there's a shorthand command for it that I never do. Could be RF. Let's see. AWS S3 RB force.
Let's see, deleting or emptying a bucket. Oh, dash force. Okay, so I'm used to dash F for using force. So looks like it's just dash F instead. So close. Dash force, I mean, that's 3 dashes and not 2 dashes. I messed up there. Okay, so dash force will do it. Yeah, that's what I thought it was F. I knew there's a way to do it. I usually, I don't know why, I think it's just out of habit. I usually delete everything recursively first with the AWS R3 RM or remove and delete everything first, but dash force works as well for you. And now the bucket by doing AWS S3 LS is gone. And so you can see how, like, if you're trying to do some things quickly or programmatically, you can, being able to run these commands can be super helpful. Again, it takes time. It takes time to learn what you can do and to know what different flags you have and stuff. There's a lot of learning here. But as much as you can, I highly encourage you to, as you're learning a new service in AWS, as you're going through and you're spending some time with EC2, go, and I don't expect you to go into I don't expect you to go into the help and try to find this. Like, Google like AWS EC2 CLI cheat sheet or something like that. And because to find EC2 instances, the way that you do it is you do AWS EC2 describe dash instances. How would you know that? Like, even if you looked at the list of all those options, how would you know that this is the thing that you need to do? It doesn't make any sense. And then it gives it to you in a weird format. It gives it, well, not weird format. It gives it to you in JSON. And so, it's helpful if you like pipe it to JQ. And the more and more you like Google this stuff, people will start to tell you how to see it better. And you can get all the information, any information you would ever want to know about your systems are here. You can find out literally everything, but it's not super easy to just know what to do. But I encourage you to, as you pick up a new service, as you're spending time getting into a new service, see if you can do a couple of things. See if you can learn how to interact a few different ways with the AWS CLI. So that is it. That's it for this evening. There are a few examples in the slides of what to do with your AWS S3 bucket. Okay. Yes, you can delete from the GUI as well. So I'll delete the other one from the GUI. That's a good question. It's a really good question. Let me delete the other bucket we made from the GUI. You can do everything from the GUI. So don't feel like you have to do everything from the command line. So if I want to delete the other Horizons bucket I made, this bucket right here, you click it. I might have to click empty first, but if I try to delete it, it says, hey, it's not empty, so I can't delete it. But if I go back and I go to back to here, and I simply go to empty, it'll empty it first. I'm not gonna delete the wedding pics. I ain't gonna make that mistake, but I'm gonna empty it first. And so I'm gonna type in Horizon 1, 2, 3, 4, 5. If they thought I was going to type this, they might be correct because they're making me type it. To confirm, oh, permanently delete. Never mind. So you gotta read. Reading is fundamental, y'all. You type permanent delete, it deletes every item in the bucket. Phenomenal, really exciting. It gets rid of everything. And now that it does that, you can now go back to the page and you can delete that bucket from here. And I can delete it and type the name of the bucket. So I paste it back in there, and now the bucket is gone. So all good. You can do it from the GUI, but why when you can pass for a hacker next to your friends and family? Mysterio, I'm with you on that. I'm with you on that. Learn a couple commands and pass off as a hacker. And what's crazy? Like, so many, there are tons of cloud engineers who know how to do almost nothing from the CLI. But when you can combine the two, when you understand how to interact with things, you can find out how to, I don't know how to work with most services. I probably know literally 0.5% of the different things you can do in there. But once you understand, once you get comfortable working with 1 or 2 services, you understand how it's going to work with pretty much everything. And you can learn, if you need to figure something out, it's pretty easy to figure out what to do. If you block public access, you don't get the S3 // or maybe I can't find the info. You should get it because that's the URL of the bucket. That's the URL of the bucket. So I have something like just can be public. Let me create one that's this one, bucket and objects not public. It's just still, so it's always S3 // and then the name of the bucket. That's what the URI always is, no matter what. Now you can't get to it. You can't get to it externally. You can't get to it externally almost ever until you change some settings. Like you couldn't just load it up in a browser or anything like that. You can never do that actually because it's through the S3 protocol, but you do get it. I had fun tonight and also convinced me to move my low traffic web hosting to AWS. Facts. So S3, if your site is static, you can host your site for almost $0, if not $0 per month. It might actually be $0, and so that's pretty nice. Or you can stick it on a server if you want. Public access will be denied. Yeah, for that public access will be denied. It's static. It only exists to show people my artwork. Oh yeah, S3 is where you want to put this thing. Please. It will save you so much. Yeah, GitHub.io is good too. I think there's value in knowing how to use, being familiar with having something in AWS. I think it's valuable, but now 100%, it's a place that's free for sure. Now the other thing, we talked about it a little bit earlier on. We're supposed to dive into. All right, we have 4 minutes. We're gonna get off at 9:30. We have 4 minutes really quick. The last thing I wanted to talk to you about is a CDN. We talked about a CDN. I can't remember if it was here or if it was in pipelines day one, but setting up static sites here is great. Or it's not even about static sites, but you can set up static sites here in S3. S3 is pretty much infinitely scalable, all great. But another way that when we're talking about serving to the masses, and we're talking about different ways to ensure that our systems can handle the load that we are trying to the amount of traffic we're trying to serve to. Sorry if you all see me like moving around. Don't forget I'm on a balance board because I'm standing up. So I was kind of rocking around while I took my glasses off because my eyes were burning. But when we're talking about serving to the masses, this is where a CDN comes in, or content delivery network. We talked about this once before, but what a CDN does is it creates a network of servers that will geographically cache your data and serve it to the people who are closest to those systems. So let's say I have a little old server in US East 1, in Northern Virginia. And again, it's a little server and it is, I'm not getting a ton of traffic, but again, I get, Oprah or Beyonce or somebody catches me and is like, I like this. Let me tell the world about them, and I want them to go to my site. I could set up a CDN, which is a content delivery network, and what it'll do is it'll put my site behind a network of servers. Okay, so what it'll do, let's say my server. Let's draw the world really quick. All right, and I did this okay last time. It's gonna be worse this time. Sure. We're just because we're going faster. There's Florida, because you got to draw Florida, and this is the world. I did my best here, okay, and it's the world, okay. Let's say my server is here, and people all around the world want to get it. A CDN, and let's put this up top. No, that's not an O. That's a C, a D, and an N. Let's say people around the world are at their houses. This is people around the world. Here are the people around the world. Actually, sorry, these aren't people around the world. These are what are called edge servers. All right. And these edge servers are a network of servers that exist all around the world that Amazon has, that aren't a part of their main kind of data center setup, but they're called edge locations, edge servers all around the world. And what it allows us to do is a CDN will take, as people around the world access my stuff. So this is a person. These are people. And I don't know why this person's living in the water, but these are people. And we might have someone over here and someone right here. Okay, these people are trying to access my website. Normally, all of their requests will go here. And my server would need to know how to serve it. Okay, or we need to have enough power to be able to serve it. What a CDN does instead is it says, cool, I will take over this, and I will take over as the geographically closest person, server to the person taking this request. This server will say, cool, I got it. I will take this request. Then what it does is the very first time a request is made, and only the first time a request is made to this server, it'll go here and it'll get that data. Okay, this red server, my main server, is called the origin, and it'll go off and it'll get the data only the first time. After it gets it, it'll serve it to the person who asked for it. Now, it'll save that data, and now anyone who attempts to access your site that's close to this node right here, they will receive data from this server and not your server. And what this does is it takes a lot of load off of your server. Okay, and then so everyone around the world, they will begin to receive data from the edge location that is closest to them. Okay, it's kind of confusing at first, but it's really cool. It's only the very first request is cached, and then it'll only serve the cached data. So there's no more processing that needs to happen, and people are getting the site really quickly. Their request isn't having to travel around the entire world. It's going super close to you. The data, eventually you set up something called a TTL, a time to live. Eventually that data will die, and it'll refresh. It'll die, and then the first time someone makes a request, the first request, it'll get new data, and then all subsequent data, it'll keep serving that cache data, and it'll make it pretty quick, and it'll make sure the data is up to date. You can also manually clear the caches as well, but it's a pretty cool way to do stuff. Yes, companies like it's like Netflix, tons of companies use CDNs. If you've ever heard of something like Cloudflare or Akamai, these are other big CDN providers. AWS's CDN is called CloudFront. Okay, CloudFront is Amazon's CDN network. Man, it is. My C's must look too much like O's. CloudFront is Amazon's content delivery network. Well, the CDN cache will get deleted too. Let me see. And what happens when we delete the origin server? Great question. Yes, if you delete the origin server, the next time the cache dies, when the cache dies, it won't have a way to get any updated data, so it'll serve an error. It'll give an error to the users. If you still have it set up and the origin server dies, next time it tries to update its data, it will no longer be able to get it. And yes, great point, Aya. A manual refresh, this is called invalidation. Should you invalidate a path, like your home page or something, and you say, hey, I pushed an update, I want people to get it immediately. It has a small cost, but it's only after like 1,000 invalidations or something. Like you get a number of manual invalidations, and then there's a cost afterwards. It is a small cost. That's good. I'm glad you're clarifying the name of these products and what they're for. And so this part is really extra. They probably won't for this level of the course. This part is extra level. So part 2 of this course, the intermediate level, we will dive deep into CDN. We will dive really deep into the different pieces to cache behaviors and origins. This information is in the slides. They might ask you like questions very generically about what a CDN is for, if you were to take the exam, but I don't even think you'll get that. I don't even think you'll. They might ask you like what kind of service is CloudFront, and you might have to say a CDN. That's the kind of questions they'll probably ask up front. But we will, in the intermediate course, dive into doing way more with a CDN. But the information about a CDN is in here if you want to grab that information and kind of know a little bit more about it. I have, it's a good thing to set up. It costs to run a CDN and S3 for my site is super duper cheap. I don't really need to do it, but I just want to set it up in case I need to do some fancy stuff. It's super cheap, almost $0, but it's pretty cool. And it's a cool piece of technology, and it really helps you to be able to scale. We would not have been able to serve those, hundreds of thousands of requests per day for the PPP loans without CloudFront. We wouldn't be able to do it, to be honest. So it really does help a ton. Okay, tons of information for a single night. Unfortunately, this class was the one that got the single day a week
So every day is probably going to feel like today, where there's just too much information, tons of information. It's okay. It's okay. You know, take a break. You know, try to recall what the stuff we talked about, and then start to dive into. You have a whole week to dive into it on your own. I know you're doing other stuff. No big deal. Again, it ain't about getting it all every class. You won't get it all every single class. You might get some. It's okay. Pick up what you can pick up, and you know, dive into that. Make sure submit that to memory, and then you know, like I said, I hope you're keeping notes of like things you're like, bro, I have no idea. We talked about this, no idea what it is. You know, write it down. Watch someone else's video on it. Hop into some documentation. Try to do, you know, hop into it a few different ways. Sometimes you just need to hear it 5 times before it sticks. It's okay. There's nothing wrong with that. Some things just won't stick. There's so much about AWS that I've read 1,000 times and I never remember. It's okay. It's completely okay. The goal is to have once we can get a pretty broad conceptual understanding of what you can do with AWS, that's what you get paid for. That's what you're getting paid for, is to understand what the heck it is that you can do with it. Once you have a general understanding of the services and stuff, companies are paying you for that, because companies don't know, like they don't know that there are different S3 storage tiers. You know that? You already can save a company money. Like, they don't understand a lot of these things. They don't understand the different classes of even EC2 instances, and that you know, some of them provide better access for different workloads, or the pricing structure. I know of companies right now who only know about EC2 instance, like on-demand instances, and have no idea that they can reserve instances or do spot instances. So, you know, you learn a little bit and you become more and more valuable each day. So, you know, start building and sharing, you know, resources that you all find available, that you find good for you and reliable and helpful. Share them with the community, share them with everybody. You know, I can't tell you all the time. I actually really do appreciate that. You all are super kind. I get private messages all the time, like, hey, do you mind if I share? Like, I found this thing. Do you mind if I share it? Share away. Like, I am not, if, you know, maybe I would feel some type of way I would never feel some type of way. I would say maybe if I was charging you guys $200 a class or something, like, no, it's my class. No, man, share all the info. Give it to me. Give it to me, because I might need to learn from it. I genuinely mean that every time I say it. Like, you know, share away. All the resources do help. You might be the catalyst of someone of sharing the perfect piece of medium that turns somebody into an expert on the subject and makes them tons of money. So please do that. But I appreciate it. Long Friday. Good job getting through the week, everybody. Come on through tomorrow for office hours if you had questions that didn't get answered. But also, it's okay not to come to office hours. I tell people, like, yo, this is a lot. Some people are coming to every single thing. That's cool. But I recommend that you come to at least 2 office hours throughout the entire thing. There are 8 weeks. I only say that just, again, because people might ask questions that you weren't thinking about. But, you know, if you want to relax, whatever you need to do to mentally take care of yourself, you know, make sure you get enough sleep, all that other stuff, that all contributes to how well you're able to go through all this stuff. Yeah, that's it. That's all there is. I'm gonna go again, spend some time with the family. I'm gonna go get some food. It's a, you know, Friday night. I also gotta do a little work, which kind of sucks. I might play some games if I have time. But peace out, everyone. Have a great weekend. We will be back on Monday with pipelines. I don't know what we're doing in pipelines, but we're doing something. Absolutely. Welcome everybody who's new. Good to have you. Who are we gonna go over to say hello to today? Absolutely. I've been quiet in the Discord for the past like week and a half because I've had a ton to do. But I'm kind of finishing all that up. I'm finishing up some so I have some cool stuff that I'm finishing up. Sundays come to the last day things are due. And then I'll be, you know, back at least for a little while, back into, you know, I can start doing some more things. But let's see who we got. Does anyone have anybody they really want to go see? If not, I'm gonna pick the only person, oh no, that I see. Let's see. Let's go over to, I don't want to go let's go recommended for me. Recommended for me is myself. We've been over to Strager. Who have not we? Oh, yep. Let's go over Griffin. Yep, 100%. Let's head over. You all should know Mr. Griffin very well. But let's raid. Cool. Let them know. Say hello. Have a good weekend, everybody. I can't wait to go get some good dinner. It always gives me this. I forget almost every day about the 10-second countdown, and I usually sign off before we get there. But now we got 3 seconds left, so you know, played it a little bit better today. Peace out, everyone. Have a great evening.